And we're saying a very good morning to each and every one of us. And thank you very much for being here again to be part of the continuation of this program. And in fact, the opening ceremony of the second Biennial International Conference of the Faculty of Physical Sciences, University of Ilorin. It's been an eventful week for us for some days now. For the past 2 days now, we've been having programs back to back, full of activities actually, because we've had a pre-conference workshop which was facilitated by Professor Mundata Lalire Yusuf, Professor of Educational Technology and former Dean of the Faculty of Education. He was here, he did that for us. And yesterday, it was the faculty lecture, which was delivered by distinguished Professor Olusegun Omoni Ige, the DG of the Nigerian Geological Survey Agency, Abuja, one of the exports of this university to the outside world. So you're welcome this morning, ladies and gentlemen. Thank you for being here to be part of the opening ceremony of the second Biennial International Conference by the Faculty of Physical Sciences. Another faculty is yet to be named, so the faculty remains the best faculty on campus. We don't have people from the faculty, so no problem. I expected you to do better than that for yourselves. So good morning to you, ladies and gentlemen, and you're all very much welcome. My name is Segun Alabi. I will be the anchor person for this event, and I want to welcome each and every one of you. Staff members, teaching and non-teaching staff of the faculty, as well as students of the faculty, guests, you're all very much welcome. I can see some pupils there also. You are most welcome to this event. Ladies and gentlemen, if truly you are here for the second Biennial International Conference of the Faculty of Physical Sciences, FAPSCON 2026, please put your hands together for yourselves. We want to welcome our keynote speaker. One of them is physically here today. She's been around actually, and it was so good to hear from her that she's been enjoying Nigeria and enjoying Ilorin. Ladies and gentlemen, as I invite her, I would like the ushers to kindly bring her to her seat up here. Ladies and gentlemen, we have in our midst visiting Professor Chemical Sciences Department, University of Johannesburg, South Africa, the Executive Director, African Foundation for Women and Youth in Education, and STI Acting Executive Director, the African Academy of Sciences, Professor Jane Ngila. For us at the University of Ilorin, we appreciate our guests better than that. You can do better than that. All right. Okay. And ladies and gentlemen, Madam was not in when I started, and we want to welcome her. And we want to also invite her to her seat up here. Distinguished ladies and gentlemen, it's so good when we have faculties having things to do together, when we have different disciplines having things to do together. I told you earlier on that our pre-conference workshop facilitator, a former dean of the Faculty of Education. And here again, we have one of the keynote speakers, former dean of the Faculty of Education. And ladies and gentlemen, let's get and welcome Professor Medina Folonsho Salman. Professor Salman currently is the Vice Chancellor of Kwara State University of Education. Madam, don't worry, in science, they don't clap so much. If it were to be education now. Okay. If it were to be education students here, they would do better than that for Professor Salman. But I can bet you, every other program we run in the university, we have it duplicated in our faculty. I hope you know. All right. You're very much welcome, madam. So good to have you around always. Thank you. And our other keynote speaker is joining us virtually. This program, the FAPSIN 2026, is hybrid. And of course, we have very many of our participants joining us virtually. And one of them also is the keynote speakers for today. Is a principal researcher, Institute of Materials for Electronic and Magnetism, PAMA in Italy. And this is Dr. Nicola Copede. Dr. Nicola Copede is joining us virtually. We don't know if the technical people can show us Dr. Nicholas. All right. He's also very much welcome. We want to appreciate him. And to all our distinguished professors from the faculty who are here, we want to thank them very much. While our professors sitting, I think we should sit together so that we don't miss anyone in the introduction. Meanwhile, I invite to join our keynote speakers up here, the Dean of the Faculty, Professor Olabisi Adele Adekeye. You're welcome, sir. And distinguished ladies and gentlemen, I'd like to also recognize the presence here today. She's been working, what you have been seeing as far as this conference is concerned is the last 2 days. But this is someone who's been working only God knows how many months. She's been working underground with our team. And ladies and gentlemen, let's put our hands together for Professor Fadipe Joseph, the chair LOC. And at the mention, man, you have to come help here. And at the mention of her name, please let all the members of LOC kindly rise for recognition. Members of LOC, for these events. Yes. We have then Professor Zain Kende Okoro, Professor Alabi, Dr. Omori Oye. We have, you are not clapping here, you don't like their faces. Dr. Bello. Thank you very much for putting this together for us. We appreciate you so much. Meanwhile, we have also former deans of the faculty. They are here. Please, let's welcome Professor Adekola. Professor Adekola, you have to join the dean here. All the former deans in the house. I can only see Professor Adekola for now. I want to believe others will be joining us later. Professor Awolola, you are recognized. Professor, our professor from mathematics, Titiloye, you're also very much welcome. Professor Alabi, we appreciate your coming. Professor Olatunji, you're also very much welcome. And to all our doctors in the house, we appreciate you so much. We thank you very much for the support always. And to all the teaching staff members and the non-teaching staff members of the faculty who are here, good morning to you, ladies and gentlemen. Yeah, you're all very much welcome. And of the greatest Unilorites, greatest of the greatest Unilorites, our students, we can do better than this now. This is the faculty, the best faculty in the university, the faculty that has produced 2 Guinness Book record breakers. All right. So congratulations to all of us on this occasion. So once again, you're all very much welcome. We're starting the program. It's an international conference. But just before we start, those of us on this side, please, we would like you to come here. Except you are a press man. Please, let's move. There are seats here. You can see where we have Professor Awolola. There are seats at the back there. Professor Alabi, please. Let's have our professors on that side. So Professor Okoro, Professor Olatunji, yes. Where we have Professor Awolola, yes, let's have you there. Professor Titiloye, I would love you to move closer to us here, sir. Sir, please, thank you. Ushers, please, those of us on this side, let's come here. Those of us on this side. Except for the LOC members. The press and the LOC members here. But every other person, please. Let's do that quickly. I'm wondering why we still have some people here. The essence of having a conference like this is not just to come around and listen to the lectures. It's for us to come around and also network. So how do we network when we are far away from one another? There is the need for us to be closer. Please, let's move closer to ourselves. Thank you very much. Only the LOC and the members of the press we want to see on this side of the auditorium. So once again, ladies and gentlemen, you're all very much welcome. Well, for the benefit of those who joined us midway, as I said earlier, it's been an eventful week for us and the faculty because in the past 2 days, thereabouts, we've been having this program back to back. The pre-conference, the faculty lecture, and today the opening ceremony of the second Biennial International Conference of the Faculty, which is tagged FAFCON 2026. And it has been themed Future Frontiers, Science and Innovations Shaping Tomorrow. As we are here also to have a look at what tomorrow holds for us. And this is the more reason why all the students in the faculty, they're expected to be here so that they can take something home from all these wonderful and amazing lecturers who are here. So once again, we want to welcome all of you. And to put the welcome address in perspectives, but before we go that route, we're here to do the anthems. So it's an international conference. So we'll start with the national anthem, the first stanza of it. Then we'll take also the university anthem. Shall we all rise, ladies and gentlemen, as we take the anthems? Nigeria. The university anthem, please. Thank you very much, everyone. Please be seated. Well, once again, good morning, distinguished ladies and gentlemen. Those that are just joining us, there are still seats here at the front. Ushers, please kindly help us to guide them. Good morning and you're welcome, ladies and gentlemen, to the second Biennial International Conference by the Faculty of Physical Sciences, University of Ilorin, FAPSCON 2026. We want to welcome all of you, the teaching and non-teaching staff of the faculty, students of the faculty, invited guests, invited speakers, participants at these events, members of the press, students of the faculty. Thank you very much for coming around to be a part of this. I'd like to start by introducing to you those that we have representing all of us at the table here. At these events, ladies and gentlemen, we have three distinguished speakers to speak to us today at this event. But don't forget, this is it's a hybrid program. As we have you here physically present, so also we have many of the participants virtually present. And so we want to thank you for joining us. And we want to also welcome all the virtual participants who are there. Please, let's put our hands together for them, ladies and gentlemen. And ladies and gentlemen, introducing to us, seated in front of us here, speakers at this event. I introduce first the Vice Chancellor, Kwara State University of Education, one of our exports of this university to other institutions to govern the place. Our former Dean in the Faculty of Education, University of Ilorin, currently serving as the Vice Chancellor, and in fact, the pioneer Vice Chancellor of Kwara State University of Education. Please let's put our hands together for Professor Medina Folorunso Salman. And also to speak to us here today, ladies and gentlemen, we are recognizing the visiting Professor, Chemical Sciences Department, University of Johannesburg, South Africa. She is also the Executive Director, African Foundation for Women and Youth in Education, and the STI Acting Executive Director, the African Academy of Sciences, Professor Jane Ngila. You're most welcome, madam. And virtually, we have our principal researcher, Institute of Materials for Electronic and Magnetism, Parma, in Italy, who is also one of the speakers to us at these events today. Please let's appreciate Dr. Nicola Copedi. And ladies and gentlemen, I'd like to also introduce to us the Dean of the Faculty, the host of these events, the man under which we have all the departments in the faculty, Professor Labisi Adele Adeke. You're welcome, sir. And also here we have the Dean of the Faculty of Agriculture, Professor Israel Ogunlade, who is here today being represented by Professor Bola Babalola. And seated up here also, we have our former deans of the faculty, and we have Professor F.A. Adekola. You're most welcome, sir. And also here we have the immediate past dean of the faculty, Professor Baba Abdullahi Alafara. And ladies and gentlemen, we have the woman who champions the organization of these events, the LOC chairperson, our distinguished Professor Lubumi Fadipe Joseph. And to all our distinguished professors in the faculty, Professor Ebi Alabi, you're welcome. Professor Latunji, you're welcome. Professor H.K. Okoro, you're also welcome. We welcome also Professor Adegoke, Professor Titi Loye. You're not clapping for them. We don't have students from their departments. Huh? Professor Guntoye, please, our professors, you have to... Professor Ladipe is there. Professor... a newly minted prof, Professor Olubumi Atolani. You're welcome. Professor Awolola, you're also very much welcome. Please, let's appreciate all our professors here. All our heads of the departments, please, let's put our hands for our HODs. HOD Chemistry, HOD Industrial Chemistry, HOD Geology, HOD Statistics, HOD Physics, HOD Chemistry, HOD Geology, Geophysics, Mathematics. Please let's put our hands together for them. So as I mentioned the departments, if you are students in the department, just clap for yourself. Just the students of the departments. Mathematics, chemistry, industrial chemistry, statistics, geophysics, geology. Which other departments? Physics. Well, so Koro, I've mentioned industrial chemistry. Thank you very much, sir. All right, we want to welcome all of you. Thank you very much for being here. I'd like to appreciate KBSC, the Ohoro of Shao, who is also a participant at this event. Dr. Job Obalowu Atolagbe, say KBSC. And ladies and gentlemen, let's appreciate pupils who are here invited. Please let's appreciate pupils of the Government Day Secondary School, Okealuko. Led here today by their teacher, Mr. Ibrahim. Miss Ibrahim Hassanat Oyinlola. Thank you. I want to also appreciate pupils of Brilliant Stars International Schools, led here today by Mr. Timothy Adele and Mr. Stephen Adedayo. Please let's appreciate them, ladies and gentlemen. Members of the press, members of the local organizing committee, we appreciate all of you. Please let's appreciate them, ladies and gentlemen. We're starting the program to put the welcome address in perspectives and inviting the chair LOC, Professor Olubumi Patipe Joseph.
Welcome, everyone. The Vice Chancellor, distinguished keynote speakers, invited guests, members of the university management, deans, directors, heads of departments, esteemed researchers, undergraduates and postgraduate students, colleagues, ladies and gentlemen. It is my honor and privilege to welcome you to the second Biennial Faculty of Physical Sciences Conference, FAPSCON 2026. On behalf of the Faculty of Physical Sciences, I extend warm greetings to everyone who has joined us for this important gathering, either physically or virtually. You are all welcome. I want to emphasize two priorities that guide this conference. Number one, interdisciplinary impact. I am a complex analyst, and complex problems rarely have single discipline answers. By bringing physicists, chemists, environmental scientists, biologists, statisticians, data scientists, and mathematicians into a common space, we encourage solutions that are rigorous, scalable, and context sensitive. Number two, capacity building and inclusion. FAPSCON is a platform for early career researchers, undergraduates and postgraduate students to present their work. And we are going to see that later in the day and the whole of tomorrow. Researchers will present their work, gain feedback, and form collaborations. We are committed to fostering an inclusive environment where diverse voices, and perspectives help shape research agendas that benefit all segments of society. To our keynote speakers, thank you for bringing your expertise and time. To our presenters and poster authors, thank you for your hard work, because we know to put things together is not a day's work. Thank you for your hard work, for sharing findings that challenge assumptions and open new lines of inquiry. I also thank members of the various committees whose dedication and hard work have made this conference possible. Let us use these days to ask bold questions. One thing we notice in Africa is that we don't ask questions publicly. And we will have questions inside of us. But for us to ask it publicly, it is a general problem in Africa. And we are encouraging everybody that is here, most especially our students, be bold to ask questions. Test rigorous hypotheses and forge partnerships that will translate science into meaningful progress. I encourage everyone to engage fully, attend sessions beyond your immediate field. Don't say because I am a mathematician, I only need to relate with mathematicians. Relate with other disciplines. Beyond your immediate field, ask constructive questions and identify collaborators. There are people here from different cities in this country. I can tell you that we have people even right from Maiduguri in this gathering. So, identify collaborators with whom you can build projects and proposals. In closing, I challenge this assembly to leave FAFSCON 2026 with clear next steps. And I promise you that at the end of this program, we are going to send out Google form to request for your feedback to help in further the subsequent conferences and to help us the more in the faculty. Please be free to fill the Google form for the feedbacks. Research collaborations formalized, policy briefs outlined, pilot projects designed, and capacity building plans adopted. By working together across disciplines and sectors, we can ensure that the frontiers we explore today become the foundations of a safer, healthier, and more prosperous tomorrow. Thank you and welcome to FAFSCON 2026. I wish you a productive and inspiring conference.
Let us put our hands together for the chairperson for FAFSCON 2026. Let us give a warm welcome to the Dean of the Faculty of Physical Sciences, Professor O.A. Adeke, for his welcome address. Put your hands together.
This is the welcome address by the Dean of Faculty of Physical Sciences, University of Ilorin, at the second biannual international conference hybrid FAFCON 2026. And today is the opening ceremony. The Vice Chancellor in absentia, all the university management team, the deans here present, the directors, heads of departments, former deans that are here present, students and members of electronic media, ladies and gentlemen. It gives me pleasure to welcome all to the Faculty of Physical Sciences Second Biennial International Conference, FAPCOMS 2026, with the theme Future Frontiers, Science and Innovation, Shaping Tomorrow. This year's conference holds special significance as we once again gather to exchange knowledge, insights, and innovations that will shape the future of our society and the nation at large. This year's conference offers a platform to address critical issues in sciences, fostering collaborations among society leaders, policymakers, academics, and professionals across sectors. The year 2024 is a memorable one as the faculty proudly held the maiden edition of this conference since the inception of the faculty in the year 2013. We have now grown to become the best faculty in the University of Ilorin. So we can clap, we can do more. We stand today as a beacon of excellence, guided by vision to a center of academic excellence and innovation. Building on the high impact legacy of the previous edition, this year's conference kicked off with the pre-conference workshop and faculty lecture with the theme Science, Energy, Transition, and the Future Economy, Lessons for Developing Countries, which was delivered yesterday here by the Director General, Nigerian Geological Survey of Nigeria Agency, Professor Olusegun Omoniyi Ige. The conference officially commences with today's opening ceremony, featuring keynote speakers including Dr. Nicola Kope, Principal Researcher, Institute of Material for Electronics and Magnetism, Parma in Italy. And the second keynote speaker, Professor Jane Catherine Ingila, the visiting professor, the Chemical Science Department, University of Johannesburg, and also Executive Director, African Foundation for Women and Youth in Education. The third keynote speaker is our own Professor Medina F. Salman, the Vice Chancellor, Kwara State University of Education, Ilorin, here in Kwara State. The technical presentation follows immediately after the opening ceremony with parallel sessions in designated venues. I extend deepest appreciation to all who made this conference possible, our sponsors, our donors, delegates, and participants. Your support not only sustained the viability of the faculty, but also strengthened its legacy as a platform for knowledge, innovation, and collaboration. It is true, your commitment that we can build on past successes and unlock new possibilities for the future of our faculty. I also want to appreciate all the hardworking members of the conference planning committees, including the faculty staff, for their dedication and sacrifices towards the planning of this year's conference. I want to recognize the support of our visionary Vice Chancellor, the members of the university management, other people that have supported this conference, our royal fathers, scholars, media executives, professionals, staff, and students that grace this occasion. Your presence shows the interest and commitment towards scientific discovery and innovations. As we commence this year's conference, remember that the strength of scientific discoveries lies in the collaborative ideas and contributions from the wealth of our knowledge. Together, we will continue to ensure that science and innovation with collaboration not only thrive, but also inspires the next generation and shape our tomorrow. On behalf of Faculty of Physical Sciences, I welcome you all once again to this second biannual international conference. Thank you for being part of our journey, and thank you for the role you have continued to play in advancing our faculty aspiration. Thank you, thank you, thank you.
A round of applause for the Dean of Faculty of Physical Sciences, Professor Oye Adekoye. Please, I'd like to call the Dean of Postgraduate School, Professor F.O. Nwosu, to the high table. Please put your hands together for the Dean of Postgraduate School, Professor F.O. Nwosu. You are welcome, sir. Put your hands together. Put your hands together. Right now, we are going to the next item in the program for today. And as we can see, the Dean of the Faculty is wearing several caps today. So I will welcome him back to give the opening remarks and also to declare this FAPCON Conference 2026 open. Please put your hands together.
I, Professor O.A. Adekoye, the Dean of the Faculty of Physical Sciences, hereby declare the conference open.
Thank you very much, the Dean. Right now, I want to invite Testimony Erioluwa to take the citation of our keynote speaker, Professor James C. Ngila. Professor James C. Ngila, please, can you please stand on your feet for your citation? Thank you, ma'am.
Standing on already established protocols, good morning, distinguished guests, members of the faculty, and fellow students. As earlier mentioned, my name is Alaiwala Yanuloa Testimony from the Department of Geology and Mineral Sciences, and I have the distinct honor of serving as a student leader here within the faculty. And on behalf of the Central Executive Council and the Student Representative Council of this faculty, it is my absolute privilege to welcome you all to today's conference. Our gathering today centers on an inspiring and vital vision: future frontiers, science and innovation shaping tomorrow. In the world of science, we know that true evolution requires a spark much like the intense pressure that drives a metamorphic transformation in the Earth's crust. Groundbreaking science acts as the ultimate chemical catalyst, speeding up the reactions that are completely shifting the strata of our global future. To shape tomorrow, we must embrace these powerful reactions and pioneer new frontiers. To guide our perspective through this deep scientific landscape, we're joined by an extraordinary global icon who embodies these very ideals. It is my utmost pleasure and privilege to read the citation for our distinguished keynote speaker. Professor Ngila is the Executive Director of the African Foundation for Women and Youth in Education, Science, Technology, and Innovation, whose main focus is to prove mentorship to women and youth in education and STEM fields. She is also currently the Interim Executive Director of the African Academy of Sciences. Professor Ngila is a member of the following advisory boards: the United Nations 10-member group for Technology Facilitation Mechanism on Science, Technology, and Innovation for Sustainable Development Goals, UNESCO International Consultative Group of Experts for Closing the Gender Gap in Science, Council member of United Nations University, the Vice President of International Organization for Chemical Sciences and Development, and other board membership, including Smart Science Africa, Global Community Initiative for Growth for Community Development, Science, Technology, Engineering, and Mathematics. Mentorship committees such as AES Mentorship Program, Kenya National Commission for UNESCO STEM Mentorship, Mastercard Global Give Back Circle for Girls in Kenya, and so on. Professor Ngila is a fellow of the following academies: the World Academy of Sciences for the advancement of science in developing countries, the African Academy of Sciences, and the Academy of Science of South Africa. She has been a member of professional bodies and societies such as Organization for Women in Science in Developing World, African Women in Science and Education, African Institute of Science, American Chemical Society, Royal Chemical Society, South African Conventional Institute, Kenya Chemical Society, and she has also served in editorial and advisory boards such as South African Journal of Sciences, U.S. Africa Frontiers in Science, National Academies of Science, Engineering and Medicine, Smith Foundation Science Fellowship, Berlin Berlin Walls Engineering and Technology, and also the Review Committee for Nobel Prize for Templeton Foundation, Laurie UNESCO for Women in Science Jury, Agro Paris Tech Water and Sanitation, RSC Group member of Open-Ended Working Group for Science Policy Panel on Chemicals, Waste, and Pollution Prevention. And she's also formerly editorial board of Water South Africa Journal and Water Research Commission. Professor Ngila has received the following awards: 2025 International Union of Pure and Applied Chemistry, IUPAC Distinguished Women in Chemistry and Chemical Engineering, 2021 Laurie UNESCO for Women in Science, 2017 African Union Kwame Nkrumah Women in Science, 2016 South African Distinguished Women in Science Award. Professor Ngila has previously held academic and management positions as follows: the AG Executive Director of the African Academy of Sciences, Deputy Vice Chancellor of Riara University for Academic Affairs, Deputy Director at the Morendat Institute of Oil and Gas, Head of Applied Chemistry, Chemical Sciences at the University of Johannesburg, Senior Lecturer at the University of KwaZulu-Natal, Lecturer at University of Botswana and Kenyatta University. Professor Ngila is a visiting professor at the University of Johannesburg. Our research work is in the field of analytical environmental chemistry, focusing on water quality, pollution monitoring, modeling methods of wastewater treatment for detecting chemical substances in water. She has mentored over 130 postgraduate students, postdocs, PhDs, MSc, and honors in chemistry and related fields. She has published over 600 publications comprising of 260 journal articles, book chapters, proceedings, and conference abstracts. Our scholarly research citation include ResearchGate H-Index 44 with greater than 6,344 citations, Scopus H-Index 40 with 5,303 citations, and also Google Scholar H-Index of 50 and over 7,323 citations. A pioneering scientist and esteemed global policymaker, and a true inspiration to the African scientific community. Ladies and gentlemen, please stand with me. Okay. Ladies and gentlemen, please stand with me and join your hands in a... Ladies and gentlemen, please stand with me and join your hands together. Let's be on our feet. I'm really sorry. Let's put our hands together in a resounding academic welcome as we usher to the podium our keynote speaker, Professor Jane Ketrin Ngila.
Good morning. Good morning, everybody. I'm so pleased that I finally get to visit Nigeria. I was talking to somebody, and I said that if you have not visited Nigeria, and you have not visited Kenya, and you have not visited South Africa, you have not covered Africa. So I visited South Africa and Kenya. Of course, I come from Kenya. And then I said, there's one, I've not yet visited Africa until I go to Lagos. So I was so happy that I managed to come to Nigeria, particularly Lagos. So thank you very much. And so when I got to the airport, I was now thinking, oh, I have to connect flight from Lagos to Ilorin. So now I'm looking to see which line I should. Before I stepped out, I was Professor Catherine Ngila. I looked, I was shocked. I said, somebody knows me at the airport in Lagos. And so the person introduced himself and he said, I'm liaison officer at University of Ilorin. I was so happy. From that minute onwards, my life became very easy because I didn't have to worry about anything. He took me around, I went for lunch, he took me to the airport. I'm so happy. When I arrived at the airport, guess whom I found there? The Dean, Faculty of Science, waiting for me. I said, I'm so honored, really. I really pleased. Professor Okoro, of course, my former postdoc at University of Johannesburg, Hussein Okoro. We also have the head of industrial chemistry, Professor Victoria Awolo. I met with her, Awolola. I met with her at University of KwaZulu-Natal, and she was a postgraduate student doing her PhD there. So when I arrived here at the Faculty of Science, she came running. She said, Professor Ngila. And I looked at her and said, I'm so happy to see you after a long time. So Nigeria is like home for me now, because I am really pleased with the kind of welcome that. But let me also start now officially just recognizing the Vice Chancellor, Professor Gewole, and of course all the DVCs. We have got to have the Faculty Dean, Faculty of Physical Sciences, Professor Adekeye, Professor Olubumi.
Well, we apologize, our keynote speaker. I'm so sorry, madam, to come in between your thoughts. And ladies and gentlemen, we welcome our Vice Chancellor, Professor Wahab Olashupo Egbewole, Senior Advocate of Nigeria, who is here being represented by the Deputy Vice Chancellor, Research, Technology and Innovation, Professor Muta Adeza Ichudayi. Well, for those who've been following situation of things on our campus, it's really a very busy week. And because of the love that the Vice Chancellor has for the faculty, this is why he said in a few minutes, Professor Tudayi will be here, and he is here. So before we continue to listen to the keynote speaker, let's invite the Vice Chancellor. You're welcome, sir.
Good morning. I'll be abiding by the already established protocols, but I'd like to make special mention of the Dean of the Faculty, our keynote speakers, and our guest lecturers, as well as our other our staff and students, our visitors to the beautiful campus that we have, distinguished ladies and gentlemen. I want to first apologize that it is little me that is standing before you. We've had a very hectic week because this week is our council week, where the chairman of our governing council is around to overlook all the meetings of council that we have. The Vice Chancellor is currently at one of those meetings and sends his apologies for not being able to come here for the opening. So I convey his good greetings, his goodwill, and his continuing appreciation of the Faculty for Physical Sciences and all its staff. The programs have been very fundamental to the development of our university, and it has shown in its support from dean to dean to dean of the faculty. the Vice Chancellor conveys these appreciations through me. Nigeria being, of course, a crude oil country and all that, we find that the physical sciences are fundamental to perhaps 80% of our value as a nation. And we continue to appreciate this in the training that is given to our students, in the interactions that we have with the policymakers and the general public. So it is with great pleasure that I'm here, and I'm deeply humbled to be here. And I also apologize for interrupting your speech. On behalf of the Vice Chancellor, Professor Wahab Olasukoegbeole, it is my distinct honor to declare the lecture open and to convey his goodwill. Thank you very much.
Thank you very much, Mr. Vice Chancellor. And ladies and gentlemen, because of exigencies of work, the Vice Chancellor might be leaving any moment from now. But we invite back to the microphone one of our keynote speakers, Professor Jane Inkila. You're welcome, Madam.
Thank you very much, Director of Ceremonies. I do appreciate and I do recognize that we have to observe protocols, Mr. Segun. I appreciate that. So I was just about to finalize just the remarks. Thank you. We just say bye to the Vice Chancellor and the team entourage. So I was just finalizing and appreciating, appreciating the local organizing committee. Of course, the chair, as we've already been informed, is Professor Olubome Fadipe Joseph. I really appreciate the lady. When I arrived, and when I looked at the profile and I saw she's a professor of mathematics. These are students seated there. A lady who is a mathematician, professor of mathematics, lady. So that is big for me because there is a misconception that girls don't do science, girls don't do physics, and because physics and mathematics are said to be very difficult. And so therefore, when you see a professor of mathematics, you stand because she must have fought a lot of stereotypes to get there. And so of course, we have got our previous presenters yesterday. I do recognize their work yesterday. And of course, today's presentations, we also have among us one of the women vice chancellors, very impressed also, because I do promote women and youth in science. Professor Biennial Salman. Really appreciate, and of course, all the other key presenters. Let me say all protocols observed because we have got deans, former deans, heads of departments, senior professors who are seated here. And so I'll just talk briefly and say all protocols observed and of course appreciate the invitation. I've already been introduced and thank you very much for the person who's read, the lady who read my bio. I was listening and I said, is that also me still? Because she read it so well that I felt so impressed that I couldn't believe that that is me. So very, very thank you very much, one of the LC members. As I start my presentation, and of course, bio has already been read, in my presentation today, I would like to look at some of the key things because I'm a professor of chemistry. So obviously I'll be talking chemistry, but because I do appreciate that among us, we do not have, not everybody here is a chemist. So I will break it down and also make it not very general so that I don't bore majority of you. So in my presentation, I just want to introduce what I do, but also talk about the Sustainable Development Goals, the United Nations Sustainable Development Goals. Very, very important. African Union Agenda 2063, very important. Science, Technology, Innovation Strategy for Africa 2034, very important. But also highlight the UNESCO Core Action for Closing the Gender Gap in Science. So in Nigeria, we don't have a problem in gender parity. Almost the numbers are equal. And in fact, we have got so many women vice chancellors here. So the talk about closing the gender gap, almost Nigeria is closing the gender gap. So I wouldn't really dwell much on that one. But then, of course, I will go into the emerging technologies, the interdisciplinarity between physical sciences, what we are doing today, and also looking at keenly what I do is water resource management, particularly water purification, monitoring of pollutants and so forth, and also highlight water scarcity in Africa, water systems in Africa and challenges that we are faced with, some of the pollutants and the impact of the pollutants, and some of the technologies that have been developed, particularly in analytical chemistry. And so I have already been introduced to that. I'm a visiting professor, but I come from Kenya. I'm a Kenyan, but I moved to South Africa about more than 20 years ago when I met with Professor Victoria Awolola. That was at University of KwaZulu-Natal, and that was, I think, 2007, 2008 there, or 2006. That's when I moved it from University of Botswana. But I started with, of course, my home country, Kenyatta University. So I went to school at Kenyatta University, and then from there I went to do my doctorate at University of New South Wales in Australia. And I came back and I taught at Kenyatta University for about 3 years. Then I moved to University of Botswana. I moved to University of KwaZulu-Natal in Durban, and then University of Johannesburg, then came back to Kenya before I retired. I call myself semi-retired because I'm very actively involved in many other things. So University of Johannesburg, which is of course in South Africa, has got 3 campuses, and it's one of the, what we call historically, not really marginalized because it was a merger. 2004, there was a merger of University of Witwatersrand, University of Rand's African University, and historically the Black University. So they merged together to come up with the University of Johannesburg. And so it has got 3 campuses. It's trying to top the chart, but of course we know if you ask many people, they will tell you number 1 university in Africa is the University of Cape Town. So in Cape Town, South Africa, and of course the rest of the other university will follow. So it is trying very hard, to take over that. But it has been globally recognized, particularly when it comes to the United Nations Sustainable Development Goals. Now, as a foundation, I started this foundation 2022, 2023, towards the end of 2022, and I just promote, the vision is just to transform lives of women and youth. I go to boys schools and girls schools. I think last year or the year before, I was invited by one of my former students, and he said that, Professor Chemistry, can you imagine the boys' school are not passing chemistry? I said, why? He said, please come and talk to the boys. So I went to talk to the boys, and when I was introduced and I said I'm a professor, he introduced me as a full professor of chemistry, and the boys now wanted to understand what does that mean. So when I started explaining, after that, the boys followed me to the car and said that we are never going to fail chemistry. If there's a professor of chemistry who is a woman, we cannot afford to fail chemistry. And so that was just a reverse psychology, making the boys also do very well in chemistry and sciences. Previously, I think 3 months ago, I was also acted before the African Academy of Sciences, which is actually a regional academy in Africa, and is affiliated with African Union. And yesterday I met with one of the fellows of the African Academy of Sciences, Professor Yukub. And I'm told that there are 2 professors from University of Ilorin who are also the African Academy of Sciences Fellows. Its mandate is to recognize excellence through election of fellows, recognizing fellows. Nigeria, we have got, and for your information, we just finished the election of the governing council members of the African Academy of Sciences, and guess who is the president? The newly elected president is Professor Friday Okonofua from Benin, University of Benin, is now the new president of the African Academy of Sciences. So the other one is advisory think tank functions to support African Union and also to implement science, technology, innovation, because science, of course, it transforms. I also sit in another organization called International Organization for Chemical Sciences in Development, which has got an office in Belgium, and I represent the emerging economies, Africa being one of the emerging economies. And the vision is just to highlight the chemical sciences and the role they play in improving the quality of life, but also in promoting sustainable development goals. United Nations Agenda 2030, we are left with about 4 years now to get there. And now I sit in the organization that we are appointed by the United Nations Secretary General. I represent Africa, and our role is to find out how far has Africa gone. For me, that is, how far has Africa gone in achieving the 17 Sustainable Development Goals. But of course, the United Nations Sustainable Development Goals are about life. It's about environment, social, and economics, as well as politics. So ending poverty is one of them, of course, but we've got 17 of them. Number 1 is no poverty. Number 2 is zero hunger. We should not have people going hungry. Number 3, it is universal health. Number 4 is universal education. Number 5 is gender equality. Number 6 is water. Number 7 is energy, and so forth and so on. Climate change is number 13. So, but then generally we say that ending poverty and deprivations, improving health, education, so forth and so on. So that is how the Sustainable Development Goals, United Nations, came about, and the list of them are there. There's a reason why I have highlighted this in different colors. It is because in 2024, I was appointed to sit in what we call the 10-member group. The 10-member group is drawn from all over Africa, from all over the world, and I was representing Africa with another gentleman from Seychelles, and he's representing small islands. So 2024, we looked at, we review five SDGs at a go. We looked at no poverty goal number 1, 2, and number 13, and number 16. 16 is about peace. It's about peace, justice, organization, transparency, accountability, and 17 is partnerships. So last year, 2025, we looked at other selected goals: good health, gender equality, decent work and economics, and also we looked at life below water, which is a blue economy basically, and of course the sustainable number 17, which is promoting the attainment of all the other goals. And then this year, we meet once or twice per year. We meet in New York at the United Nations headquarters. And so this year we were looking at clean water and affordable energy, industry innovation, sustainable cities and communities, and also back in number 17, which is the partnership, so that we can be able to attain the goals. Now, United Nations covers all the countries in the world, but Africa, we also have Agenda 2063. That is the African Union 2063. But under the African Union 2063, we also have the Science, Technology, Innovation Strategy for Africa, STISA, what we call STISA. STISA 2024 just ended. Now we are STISA 2034. We have started STISA 2034. And STISA 2034 is focusing on agriculture, health, ICT, energy, environment. 2024 was looking at eradication of hunger, food security, preventing of diseases, so forth and so on. So you can see that African Union and United Nations are talking the same language. We only focus in Africa on what is a priority for us in Africa. But we have got gaps for us to be able to attain the Sustainable Development Goals and also Agenda 2063, and particularly Science, Technology, Innovation Strategy for Africa 2034. Some of the key gaps that have been identified: inadequate coordination of STI initiatives, access to finance is, of course, remains a problem, weak intellectual property, digital inequality, because we are all going digital. So if there is inequality in access to digital tools, then we are disadvantaging. Neglecting indigenous knowledge. Indigenous knowledge, very important. Data insufficient. We have got data, but we don't coordinate data. Limited gender inclusivity, of course, continues being one of the issues, but we also have to network and also equalization of all areas. Now, UNESCO, I also sit in the committee for UNESCO, as I was introduced, which is a committee that closing the gender gap. And what we are simply saying in that committee for UNESCO is that we have to dismantle gender stereotypes. I started by talking about, you cannot tell the girl, your daughter, that don't do this subject, don't do mathematics and physics. These are areas for men. Please don't do that, because we know they can do it. And so this is what we talk about, gender stereotypes, opening pathways so that the girls and boys, anybody, whoever, if you want to do sciences, do sciences. If you want to do law, it's fine. But don't say you can't do this. So this is what we are trying to say, open the educational pathways for girls and boys so that they can choose whatever they want to do. And the other one is, of course, a safe working environment for women, particularly in architectural, in engineering, people who are in electrical, mechanical, and so forth and so on. So that they can also be supported to do that. Now, I'll now start looking at some of the emerging technologies interdisciplinary, because we are talking about physical sciences. But of course, physical sciences is very close to engineering. So therefore, engineering, we come up with products in the physical sciences, but the engineers will have to upscale it. And so therefore, we are interconnected, all of us. So some of the emerging technologies and the disciplinary frontiers, some of the key highlights: artificial intelligence, which is accelerating the scientific discovery, quantum computing, nanotechnology, which is some of the area we'll be talking about today, sustainable energy, and so forth and so on. So if you look at the areas that are frontiers in science, and particularly in physical sciences, you see artificial intelligence is there. And yesterday we was lucky that Professor Yusuf took us through the artificial intelligence and some of the application of that. And so you have to look at the autonomous discovery of materials, machine learning, very, very important, data-driven modeling, very important, integrated protonics, very important, but also look at quantum engineering. So you see physical sciences engineers are talking very similar language, because you need mathematics, you need computer, you need all that. So quantum computing, utilizing principles like superposition and entanglement of quantum computing, quantum sensing, advanced superconducting sensors. Some of you electrochemists are also doing sensors. Quantum teleportation. So these are areas of interest. Other area of interest is advanced materials and sustainable technology. Under that sub-theme, we have got green energy. So we are thinking of how to make energy green so that we can get rid of fuels, fossil fuels. Neuromorphic, when we are looking at the computing devices. Next generation lighting, some of the materials that are being generated. LEDs, complex systems and interdisciplinary frontiers such as soft material. Of course, we are coming to fluid mechanics, dynamics, and so forth and so on. Biophysics, very, very important. As we continue with the developing sustainable materials and processes of pollution control, of course, some of the key areas we look at, utilizing natural biopolymers. I am always happy when I see somebody is doing research. Maybe you are using maize towels, we are using algae to clean water and so forth and so on, because that is green. We are not using chemicals that are going to destroy. Bioengineered microbes also. Also waste, how we are treating waste so that we can be able to have zero discharge. Green science, very, very important, because green science, we are saying that is sustainability, and it promotes interdisciplinarity also in terms of the focusing of the technologies, products, chemical processes, so forth and so on. As we continue, you see some of the, again, materials, sustainable materials. I've talked about the bio-based adsorbents and membranes. I'll be touching base on membranes, particularly nanotechnology, utilization of membranes, nano-engineered materials, waste vaporization, sustainable processes, and we've talked about, we have looked at the green side remediation, bioremediation, because every time you mention bio, of course, you know that is nature taking care of. So when it comes to the water challenges that we are faced, which is the sustainable development goal number 6, clean water and sanitation, the question now is, why do we have water scarcity and how is it impacting Africa? We are told that there are 2 types of water scarcity. We have got economic water scarcity and physical water scarcity. Now, physical, if you look at the countries in the north, in North Africa, we will see Tunisia there, Algeria there, and all that kind of thing. But those countries, because of oil and other resources, they have now turned their desert into getting water. Now we have got another problem, which is a second type of water scarcity, and that is the economic water scarcity. There's so much water everywhere, but there's nothing to drink. And so the question is, what is the problem? The problem is infrastructure. Infrastructure, water systems, you cannot sustain water pumping, so forth and so on. So that is where Africa, we have got our biggest problem sits in the infrastructure, and that is the economic water scarcity, where we are not taking care of the systems that provide us in water. So Africa is dealing with both economic and physical scarcity. Physical for those areas which are desert, like Southern Africa, Namibia desert, and so forth and so on, that is physical. But we have got water in Kenya, in Nigeria. The question is why some of the taps are not producing water. So we have to take care of the infrastructure. Now, we told that 71% of the Earth's surface is covered by water. 97% of the Earth is covered by salty water, so it is not available for us to drink. And 2% of that water, of that percentage that is left, is frozen water, and less than 1% is water which is unevenly distributed and not always available, and we are competing with the industry. And so therefore we have to come up with methods of treatment of water. Nanotechnology is one of those technologies that we are using. The only challenges with nanotechnology currently is that it has not really gained a lot of traction, and the reason for that is because of the techniques that we are using. They need to be friendly, and also cost affordability. Affordability is one of the things that we have to look at. We also have to think of some of the impact in global impact. We are told that by 2050, about 4.3 billion people will not have adequate water, and a child dies every 15 minutes due to lack of clean water. 80% of the hospital visits relate to the use of contaminated water by WHO, and 25% of the children who die before the age of 5 years worldwide die because of water-related diseases. So we cannot underscore any further the importance of water. We all know how water is very important. But of course, some of the factors that are affecting the water scarcity: global climate change, we can't run away from that; population explosion, industrial discharges, we are throwing pollution, we are polluting water day and night, which is really wrong. Lack of smart meters for us to be able to have resource management. And so therefore, these are some of the challenges we are faced with in terms of, and of course, the wastewater from industrial effluents. Some of the methods that are available for water treatment, we can categorize them as physical methods and chemical methods. The physical methods, we are familiar with them, like screening of the waste, polluted water, we have to remove the plastics, so forth and so on. The chemical methods, we have got chlorination, ozonation, neutralization, coagulation. We are using chemicals to clean water. And we also have biological methods, like, for example, aerobic digestion anaerobic digestion, some of the methods that we are looking at. Some of the effects for the schools that are here, effects of organic pollutants and also inorganic pollutants. Pesticides, we say that they are cholinesterases, that is enzyme inhibitors. So therefore, if you have got presence of pesticides in water and you drink that water, it's going to interfere with your enzyme operations or processes. Bioaccumulation of these pesticides in the body will cause destabilization of the metabolism. But also some of them are carcinogenic. Carcinogenic means cancer. They cause cancer, others mutagenic, which means that they are going to change your genetic mutations and so forth and so on. Some of the affected organs or systems, developing organs that are not, so if a child is exposed at an early age, some of the disadvantages of malfunction, we are going to see lack of developmental organs that are not endocrine disruption, that is glands and hormones, immunological systems affecting the immune system, nervous system, so forth and so on. The metals that, some of the impact or the effects of metals, like for example, lead is said to be a neurotoxin, so it affects cognitive development. Mercury is also said to be a neurotoxin, nervous system. Arsenic is there, cadmium is there, chromium is there. These are all highlights of metals, but doesn't mean that they are the only metals. Now, talking about the recent advances in water treatment methods, using analytical techniques. And so we can categorize some of these recent methods in water treatment as fluoroalkyl substances, or PFAS. So this can be done, we do that through destruction using the UV, that is ultraviolet. Technologies such as reductive defluorination can be able to take care of that. We also have nanotechnology. I said that I will be talking about nanotechnology later in a bit of depth. Advanced oxidation methods, utilities that are increasing, such as using the ozone, ultraviolet radiation, biomimetic membranes, that I will also talk about membranes a little bit later, and smart water metering are some of the recent advances in water methods and techniques. Now, since I'm an analytical chemist, also I'm a chemist, so therefore I also have to highlight some of the techniques that are available for analyzing of pollutants, okay? So in analyzing of the trace metals, we think about some of the technologies or techniques or instrumentation, such as mass spectrometry, yes, inductively coupled, but that is now going to a lot of details, flame atomic absorption in the laboratories, graphite furnace. We also have the organic, determination of the organics, such as mass spectrometry, gas chromatography, so forth and so on. So some of the technology, and I said I will zero in a little bit about nanotechnology. And so the question now is, what is nanotechnology? Because we talk about nanotechnology all the time. And the simple definition of nanotechnology, we say nanotechnology is manipulation of matter on an atomic, molecular, and supramolecular scale, okay? And so the definitions, nanotech is the science, engineering, technology conducted at the nanoscale, which is about between 1 and 100 nanometers. Nanotech involves the study of applications of extremely small things, and we find nanotechnology in chemistry, in biology, in physics, in material science, engineering, so forth and so on. The most important thing is that it is the technology that we are using that is at minute scale, and the importance of that is because of the surface area. If you expose reactions on large surface area, the efficiency of that reaction is high. But where did the nanotechnology come from? We are told that the concept of nanotech was actually started way back in 1959. But only about 2000 in Africa, we started now talking about nanotechnology by somebody, professor physicist, Richard, who is a physicist, And he came from California Institute of Technology. Then later on, in 1974, we got Professor Taniguchi from Tokyo University of Science, and he's the one who coined the word nanotechnology. That is just the historical. But let's see some of the examples of nanotechnology. So why is the nanotechnology important? But how do we know that these materials are nanoscale? Because we talk about nanoscale. For you to talk about nanotechnology, we are using materials at nanoscale. So we see them through high-powered microscopy and so forth and so on. And just to look as an example, nano dimension is about 1/9 meters. So if you take a meter, and if you can divide a 1 meter and you divide it in 1 billion parts, one part of that 1 billionth is a nano. And so that is how small it is. But if you try to put it in perspective, you see that for you to see DNA is in nano scale, bacteria is in micrometers, and if you look at, like, say, for example, a drop of water, and thank you very much for the water. So if you look at a drop of rainwater, that is in millimeter scale. So millimeter drop of water, bacteria, micrometers, and DNA, which you can't see unless you have got a microscope, high-powered microscopy, that is in nanoscale. Now, so nanotechnology involves ability to see. So it is a technology that we use it so that we can be able to see very small, tiny things that we can't see otherwise. And so it involves the ability to see and control individual atoms and molecules. We cannot see these small things with a naked eye, so we have to use high-powered nano instruments, such as high-resolution microscopy, and so forth and so on. But what are the applications of nanotechnology? And also some of the spin-offs. We see nanotechnology is being used in various, I'm sorry that I've not been, to control both the to control both the mic as well as looking at there would be a problem. So let me just bear with me. So we can talk about nanoelectronics, nano construction, bio, nano productive, and so forth and so on. As in fact, we are also using nano in energy defense, nano in transportation, nano in cosmetics. So the nano materials that we are talking about are already being utilized in various applications. As an example, we are seeing that some of the polymer nanocomposite materials, these are nanocomposite, a combination of polymers and matrix inclusion, but also, so we always say that for you to know a material is nano, has got nano dimension, at least one of the dimensions in that material must be nanoscale. And so we talk about nanoparticles, nanosheets, nanowires, and so forth and so on. We also talk about nanofillers, and if you look at some of the organoclays, carbon nanofibers, carbon nanotubes, metallic nanoparticles, these are different fillers that if you put in the material, then you can manufacture nanocomposite materials. Now, I talked about analytical chemistry. So, of course, my core, I did my doctorate in analytical chemistry, and so some of the students that I've supervised in analytical chemistry, like trying to utilize analytical chemistry for improving, either you are doing analysis, and how to improve the analytical process by removing what we call the sample matrix. So you use solid phase extraction for preconcentration, and an example of this is a lady I supervised at University of Johannesburg, Professor Dr. Valerie, who worked on development for the determination of selected organic pollutants in wastewater. And so if we start with the first diagram on the left-hand side, on my left, you see there's a lot of polluted materials there. And so she was interested in trying to analyze what is in that waste. And so that waste, if you discharge that in from your house, it goes into the wastewater system. from the wastewater system. She was able to collect samples from the wastewater system. But after that, she has to extract so that she can be able to isolate the analytical, the materials that she's interested in removing that from the waste, what we call the matrix. And so from there, she was able to analyze. But of course, for you to be able to do that, you have to use various technologies. Chromatography is one of them, so that you can be able to separate. Chromatography separates materials, analyze that you're interested in. And then, of course, using high-powered instruments so that you can be able to analyze and detect and quantify for you to know what is the concentration in each one of them. Mass spectrometry is one of the technologies that we have used. So she started by the sample collection, then she takes it through the purification of the sample through solid phase extraction, then she takes it to the instrument using chromatography to separate the mixtures, and then she analyzes using high-powered mass spectrometry. And then she can do so that is typically what an analytical chemistry does. Now, in her work, she also looked at synthesizing the materials, carbon nanodots, okay? And these materials were important for her to be able to improve the efficiency of the detection of the materials of the analyze that she's interested in. And of course, you can be able to compare what she synthesized, the nanodots, and also the commercial materials that are available for solid phase extraction and so forth and so on. And so she also used multivariate optimization approach for interactions of variables and so forth and so on. And in terms of the multivariate optimization, access to variables to be investigated, then apply appropriate models for you to be able to achieve that. I've talked about the chromatography and some of the conditions just as an example, and I think people in physical sciences across the board, I think we all use chromatography for one thing or the other. I won't go into the details because time won't allow, but that is just an example of the chromatographic equipment. These are some of the results that you get when you separate materials. You separate using chromatography, so you can be able to say, for example, in this particular case, she was able to see methyl, parabenes, propyl, parabenes, so forth and so on as different individual organics. These are some of the optimization of parameters. You have to optimize parameters for you to be able to get the results that we are looking for. And some of the results that she was able to receive, I think I won't go into the details of that, just to demonstrate that the fact that she used what we call the solid phase extraction to clean the samples and then used the instruments for her to be able to quantify the pollutants that she's trying to analyze. In terms of the nanotechnology, we have used different materials. Like, for example, I talked about biomass. In our research, we have used algae, we have used sugarcane barks, rice husks, maize tassel, seaweeds. These are different materials that we have used. And the reasons why they were useful is because of the functional groups, such as the carboxylate, hamides, diols, sulfonates, so forth and so on. Membrane technology, when we talk about membrane technology, it can become in different forms. So we talk about reverse osmosis, ultrafiltration, water softener, carbon filters, and so forth and so on, membrane filters. And so these are just a mixture of so many of these ways in which you can be able to use the nanomaterials for the water purification. As an example of nanomembranes water filtration, I think that's just an example to show how the mechanism, the details of how the membranes operate when you pump in the water, how the membranes is filtering the water. And also if you take a cross section, you take it to the instrument, you can see this is in nanoscale. The materials are in nanoscale. Again, these are just some of the setups using the membrane technologies for water purification. Then I've also supervised another student, Professor Tumbi, and he was electrospinning materials so that he can be able to package them in cartridges. I will jump the chemistry part of it and just show some of the products that we have been able to get, whereby he was able to get He produced nanocomposite fibers and membranes that are combined together to improve the efficiency of the water cleaning using electrospan. This is just details to show how you can be able to use sunlight for you to degrade organics such as pesticides, the mechanism that is involved for chemistry. Some of the results that Dr. Tumbi was able to get using chromatography, gas chromatography, and mass spectrometry. And coming to the end, mathematical modeling, we have also done mathematical modeling. This is Dr. Anthony Juguna, who was a chemical engineer at University of Johannesburg. And if you look at very typical of a scheme of wastewater, pumping wastewater, you are looking at the preliminary wastewater treatment, and then you go towards the end where you get different chambers that you can be able to analyze. Typical of a wastewater treatment plant. He was using mathematical modeling, so mathematicians who are here, we work very closely with the mathematicians. He was using mathematical modeling for him to be able to optimize the wastewater treatment. And this is just the details of the mathematics parameters that he was trying to optimize. As I finish, I got a postdoctoral student who came from University of Cape Town Peninsula, and that is in the name of Professor Okoro. He came to UJ, University of Johannesburg, 2016, but this man doesn't sleep. Within a very short time, he published like there was no tomorrow. And so the chemistry department, the chemical sciences department was very pleased to have him as a postdoc. Unfortunately, I left University of Johannesburg 2017, mid-2017, so therefore, because I was his supervisor, when his term came to an end, we could not renew his contract. But thank you very much, Professor Okoro. Thank you. And just simply to highlight some of, some of the opportunities that I've had, and it was announced about the L'Oreal UNESCO Awards. That is me in Paris, receiving the award in 2022 at the UNESCO headquarters. Again, that is just promoting women in science. In my speech, I was talking about water treatment and also some of the methods that we have been able to. That is me in Kenya trying to collect water samples, and I went through, they take a video for you to show some of the things that you do. For those who are doing physical sciences, and this is my last slide, is that, I thought doing physics and chemistry and mathematics was all I needed. Only to realize that those are some of the things that you get, but in the world, the real world out there, you have to learn so many things, what we call the soft skills. So I was in Paris, 2023, and then I was just walking and I saw somebody who looked like me. I looked very keenly, I went close, I saw Professor Ngila. I said, this is me, because of the L'Oreal UNESCO Award that I got in 2021, 2022. So I called one of the people who was passing. I said, please come and take me a photo. They passed. I saw another one, please come and take me a photo. They still passed. Then I saw two Chinese girls. Then I started pointing, me, here, take me photo. The problem was because I don't speak French. And I said, if I went back to school, I would be learning French, Arabic, and any other language, because Chinese as well, because you have to learn language if you are going to be a global citizen. Thank you very much. And so that is me, 2017, the African Union headquarters in Ethiopia. 5 women got awards. The lady who came from West Africa was Professor Rokia Sanoko from Central Africa. But we also had an associate professor who came. I think these things are mixed up. West Africa was Professor Olu Owolabi Mamijao. She was recognized from West Africa, and that must be from Nigeria. So therefore, thank you very much. And these are some of the organizations that have supported my research over the years. Thank you, and may God bless you.
Well, distinguished ladies and gentlemen, please another round of applause for our keynote speaker, Professor Jane Catherine Nkila, a visiting professor, Chemical Sciences Department, University of Johannesburg in South Africa, an executive director, African Foundation for Women and Youth in Education, and STI acting executive director, the African Academy of Sciences. Another round of applause for her, please. You know, personally, when I see people studying chemistry, I have a lot of respect for them. And when the person is a woman again, I have additional. Because chemistry is the reason I didn't study sciences. I used to be a science student back in secondary school. I had to just leave that. If I preferred physics to chemistry. For you to know how bad it was for me studying chemistry. So when we have people studying chemistry, you know, I love my heart for you. So to all the chemists in the house, kudos to you. Well, I believe I'm not doing badly where I am now. All right. Thank you very much, madam. We appreciate you so much for speaking to us in the last 40 minutes or thereabouts. We appreciate you so much for sharing parts this from your pool of knowledge on this with us. We appreciate you. Thank you so much. And ladies and gentlemen, without taking much of our time, we're moving to the next speaker. This time we'll be speaking to us virtually, and we're talking of the principal researcher, Institute of Materials for Electronic and Magnetism, Parma, Italy. Talking Dr. Nicola Coppotti. I hope he's ready. Hello. Okay. Dr. Nicola, you're very much welcome.
Thank you. Thank you very much. Thank you, everybody, for this invitation to this very important international congress. Thank you.
You're welcome. From here, we're still in the morning, so good morning to you. And we're handing the microphone over to you now to speak to us in the next 30 minutes or thereabouts. So it's over to you. You take it away from here.
Okay. I try to share my screen. Can you see my screen? Can you hear me and share my, can you see my screen?
Well, Dr. Nicola.
Yes.
Okay. While you're trying to get your screen, while you're trying to share your screen with us, we'd like to take your citation. So I'm inviting Professor A.B. Alabi to take the citation of Professor Dr. Nicola. You're welcome.
Thank you very much.
The Vice Chancellor, Professor Wahab Olashipo Egbewale, SAN. I want to stand on the already established protocol. It is my joy this morning and honor, great privilege to introduce my friend and a collaborator to the Department of Physics, University of Ilorin, our dear friend, Dr. Nicola Coppotti of the Institute of Materials for Electronics and Magnetism, Parma, Italy. Dr. Nicola Coppotti graduated with a degree in physics from the University of Pisa in 2001 after completing a thesis titled Near Field Microscopy of Superconducting Film Deposited by Laser Ablation. Now, he later earned a PhD in physics from the University of Trento in 2006 with his thesis entitled A Novel Approach in Nano-Hybrid Material based on the co-deposition of supersonic molecular and cluster beams.
Now, since 2012, he has been a researcher in bioelectronics and organic electronics at the Institute of Materials for Electronics and Magnetism in Parma. Now, previously, he worked as a researcher at the Institute of Photonics and Nanotechnology, that's in Trento, and then at CAM, a spin-off company of the University of Magma in Grecia, in Chasenzo. His research focuses on materials device and technology for innovative integrated biosensor. He's also a co-founder and president of PlantBeat, a spin-off company of MMCNL Parma. Now, throughout his career till now, Dr. Nicola Copedi has developed several groundbreaking sensing technology, which includes what is the pioneer, the creation of biosensor based on organic electrochemical transistor embedded in textile fabrics for real time. Also, non-invasive monitoring of physiological condition through biofluid like sweat. Its research on porous organic material led to the invention of soft integrated pressure sensor made from polymer and nanocellulose for biomedical application. Additionally, he developed the biocompatible electrochemical sensor for real-time in vivo plant monitoring, aimed at precision agriculture and water resource optimization. His work also includes biosensor for cancer screening, capable of detecting circulating tumor cells directly from scriptotium blood sample. He has played a key role in the development of biosensor with a high degree of integration in both living environment and industrial material. His expertise spans from material research and device design to the realization of complete prototype and sensing system. He holds several patents for innovative device and collaborate with companies on several applied research projects. Dr. Nicola Copedi has authored over 100 scientific publications, to be precise, about 143 in all, in international journals, and has presented in his research at more than 50 national and international conferences. He's an inventor of 6 international patents and 4 Italian patents. Please join me this morning to welcome Dr. Nicola for his presentation. You're welcome.
Thank you. Thank you very much. Thank you very much.
All right, Dr. Nicola, you're speaking to us in about 30 minutes.
Okay, can you see my screen? Can you see my presentation?
Yes, we can.
Okay. Thank you very much. Thank you for your kind introduction, for inviting me in this wonderful congress. Okay. I want to thank you, everybody. I want to thank the Vice Chancellor, Professor Guilove, and I want to thank you all the deans of the various faculties, especially the Dean of Faculty of Physics, Professor Adikeye. I want to thank you all directors, the head of departments, the member of the local organization committee, and all the fellow researchers. All the undergraduate and postgraduate students and you, ladies and gentlemen. And I want to thank you also, my dear friend, Professor Alabi Adereni, who contacted me and invited me in this congress. Thank you very much, everybody. So I am from Parma in Italy. This is my institute. It's the Institute of Materials for Electronic Magnetism. In our institute, we try to exploit the properties of different materials to obtain devices, especially sensor devices, that have different properties, that have unique characteristics, and try to integrate different functionalities and performances. During the years in our institute, we develop different kind of materials to deal in different kind of materials that we use for electronics. First of all, in our institute, there is a tradition for inorganic materials like crystal materials that are bark materials that are similar to crystal silicon but are not made of silicon. For example, they are made of zincum, of cadmium zinc tellurium, and they are used for the sensor for X-ray radiation, and they are bark materials that were built by different techniques. Then we have a tradition of working with the nanomaterials, nanostructuring materials, especially nanoxides that we prepare from chemical waste, and we realize with this nanostructure, especially zinc oxide, tin oxide, titanium oxide, we realize the gas sensor and different kind of devices using nano shapes approach. And then we have another kind of materials that we use in the Institute for Electronic Research. These are the organic materials, in which is more now my area, in which I work mostly, and are based mostly on conductive polymers that we use to make a sensing device, and to use their flexibility, their ability to be biocompatible, to make different kind of devices that can be used for different applications. In this presentation, I will show you that we start from the core of the materials, from the preparation of the materials to build the setup, the different layers for the devices. Then we realize in our institute the devices, we make the characterization of the devices, and then if we are able, we also try to prepare some prototypes for application, and then look with these prototypes at the real application that can go in the industrial world, can be useful for spin-off, for startups, and also for industrial application. So we are trying to work on these all structured, especially looking at the different property of the materials. In this presentation, I will show you different approach that try to exploit the property of the substrate. So we will look at the devices that are made directly on textile substrate. They try to exploit the property of the substrate to absorb the fluids. Then I will show you some devices that are made with organic materials on the nanostructured surfaces made of micropillars of substrate that we try to exploit their hydrophobic properties. And then I will show you how to rebuild the electrochemical sensor and also other kind of sensor like pressure sensors made with polymeric materials for different application. As you know, nowadays the world of sensing devices is more focused to realize devices that can be used in real life, in everyday life, and can monitor the physical properties, the physical condition of a person possibly continuously, and also without creating problems to the person. So they must be very flexible, very biocompatible, and must be non-invasive. So with this technology, you can build devices that can be wearable devices that can monitor different biological and physiological property of the person. So the idea is to collect continuously this data and to use machine learning approach and big data approach to understand what is happening to the health of the person. In such a way, we can have important information that can contribute to the health, to the well-being of the person, reducing the risk and improving the health of the population. I just go directly in one example in which we use organic materials to functionalize textile substrate and realizing textile biosensor for non-invasive sweat monitoring. Why monitor the sweat? The sweat is an organic biofluid that is emitted by the body for the correct temperature keeping of the body, but it's come from the blood from the cell that are under the skin, and the cell are in contact with the blood. So in the sweat there are a lot of biomolecules that are for medical interest are very useful. In particular, we can find in the sweat the salts, sodium, potassium, and calcium. You can find glucose that comes directly from the blood, and you can find lactate. And you can find also interesting molecules like cortisol for the stress, or adrenaline, or also hormones. And if we know all these biomolecules from the sweat, you don't need to take up the blood samples, and you can monitor the person continuously in non-invasive way. So the goal is to collect the sweat directly on the substrate of our sensor. So we want to use a textile substrate in which the collection of the sweat comes naturally because the textile absorbs naturally the sweat. Then we perform the measurement in the textile, and then the sweat evaporates. So we can have a constant flux absorbed by the material, and we can monitor the sweat in time, not only for one moment, but continuously to have a constant monitoring. We use as material for the functionalization of the textile a conductive polymer that is PEDOT PSS that has very different interesting properties. First of all, it's a very good conductor, and second of all, the PEDOT is sensitive to positive ions. This means that if you make this conductive polymer, you make a film, you make in contact with a solution, if the solution contains positive ions, you reduce the conductivity of the polymer proportional to the number of ions that are in the solution. This allows to use this polymer as an important ingredient for producing biosensor, especially biosensor in liquid and biofluids. This means that we built an architecture of this biosensor that is called organic electrochemical transistor. This means that we use a transistor architecture to produce our biosensor, and the device is made in this way. We use a film of conductive polymer that you see here on top right as the basis of this sketch. In the conductive polymer, we contact this film that we realize with two electrodes, and we apply voltage, and we make a current go through these conductive polymers. Then we put the polymers in contact with the fluid of the sample, and we apply another electrode in contact with the liquid, with the fluid, and we switch on a potential on the gate that forces a positive potential that forces the positive ions to be injected into the conductive polymer. This injection of ions into the conductive polymers changes the conductivity of the layer, and this reduces the conductivity of the layer proportionally to the number of ions that are in the liquid. In this way, we can use this architecture to build a biosensor that is sensitive to positive ion in the liquid. The fact that we have an architecture that is a transistor, we can also exploit its amplification, and we can have a high sensitivity, a very sensitive device that can be controlled in time. So we decided to build this device directly on the textile substrate. We functionalize the textile substrate directly using a dipping solution. We built this device using a different technique. We just dip the textile in the solution of PSS and make a thin film on the surface like in these images that are all covered with PSS that is conductive, because you can see here at the scanning electron microscopy is very dark and conductive. Or we use eject printing, 3D printing, or also screen printing technique to realize a series of devices directly on the textile. If we measure the results of this building of this device on the textile, we can see that the current applied in the channel of the transistor reduces as we increase the gate potential. And so this means that we are closing our channel in the transistor. These are all the electrical characteristics of the transistor that are working. So we are able to build a device like this on the textile, and we use this device to monitor the concentration of sodium in the sweat. In particular, you see at the different concentration, the sodium changes the conductivity of the device, and we can have a response proportional to the concentration of sodium. With this idea, we try to apply this simple device directly on the skin of the person, and we try to use to monitor the athlete's performances. So in collaboration with the company, we developed an electronics that can read in real time the characteristic of the sweat, and this sensor that is made by textile and can absorb the sweat directly on the surface of the skin and monitor the concentration of sodium and monitor the volume of sweat that is being emitted by an algorithm that calculated the volume of the sweat. So here you see an application. This is a man running, and you can see here in the top left there is the volume of the sweat emitted, and then on the bottom you see the concentration of the sodium that at the beginning is not enough, and then starts to go up, and then you see as time is running there are changes in the concentration of sodium in real time. Then you can make an integral of this amount of sweat and this amount of sodium emitted, and you can plot this sodium concentration and volume of the sweat emitted for different moments, for different running events. In particular, bottom right, you can see that you have training events and you have also competition events in which the sweat and the emission of salts are higher. This means that we have a device that can monitor the athlete during the effort, during the tests, the competitions, and can tell you if the athletes are dehydrated, if they lose too much salt, or they lose too much water, and how to reintegrate these elements. You can also compare the emission of the sweat and the emission of the salts to the kinetic energy to understand if the athlete is working, is training properly. If you have a high emission of sweat and low kinetic energy, it means that the athlete is not trained. If you have a low emission of sweat and high kinetic energy, you have a very trained athlete. So with this instrument, we apply, for example, in cyclists, to monitor cyclists. We can see that during a long run, there are many events that increase the fatigue, increase the emission of sweat, and changes also the emission of salts. And we understand that there are different physiological conditions that can change these parameters and tell you if the athlete is working correctly or not. With this device, we are able to monitor the sodium, but if we apply the good thing of these devices is that they are very sensitive, very stable, and they are easy to print and to use on wearable devices. They are biocompatible, but they are not selective. So if you want a specific analysis, a specific biosensor, you have to make a specific functionalization to improve the selectivity of the device. So in this case, after we built the first device for sodium, we improved the selectivity of the device, adding a ion selective membrane on the top of the PSS conductive film. With this ion selective membrane, we apply a potassium ionophore, in which let only the potassium cross this membrane. So we built a device that is selective to potassium, and we are able to reduce the sensitivity to sodium, increase the sensitivity to potassium, and you can see that on the right, the potassium is much more the device is much more sensitive to potassium and is more selective to potassium. We built the same with a iono selective membrane that select calcium, and so we are able to build a device that is specifically selective to calcium directly on textile. And then we start to look at different other functionalization that can improve the selectivity, also not only for salts and positive ions, but also for specific molecules. Maybe exploiting the interaction with specific enzymes. So in this case, we look for a specific tyrosine, that is a specific ion, a specific neurotransmitter. We use the enzyme of lactase, in which we make a reaction that can produce ions, and we can detect these ions produced by the reaction. And so in adding this enzyme to the device, we are able to selectively detect tyrosine using lactase. With the same approach, we add the enzyme for lactase oxidase to detect lactate. That can be useful to understand the muscle fatigue in the sweat. So we were able to a specific device for lactate. And also we try to approach different technique to make these devices more and more selective. So we use nanoparticles, polymeric nanoparticles made by imprinted polymer nanoparticles, in which we prepare around a molecule of interest. In this case, there was a molecule of glucose. We built nanoparticles of polymers that have the perfect shape of the molecule. Then we wash away the molecule of glucose, and we have an empty nanoparticles with specific holes that are exactly the shape of the glucose. And we use this nanoparticle inside the PSS to enhance the sensitivity of the device for glucose. And here you can see the response to glucose is much higher with respect to other sugars like fructose. And so we were able, using this nanoparticle, to increase the sensitivity to glucose. These are the different devices with the glucose response that is higher and the fructose response that is lower. With this approach, we try to build a complete device with different sensing device made by organic material, all together in a wearable setup, in which we have a textile here that absorb the sweat, send the sweat to all the devices that are on this round shape array, and here you have the channels to let the sweat evaporate, and with all these devices connected to an electronic. These are the different parts of the device that can be printed by lithography. This is the paper absorbing material. and we try to connect all together the device, and is in the center. You have the absorption, and then the sweat can go directly in all the different devices that are on the array. And we try, for example, for the glucose, we reveal the glucose selectively. We have a signal that is increasing in presence of glucose, only glucose and not other material. And we test it on the body. In case of for glucose, in case of an event that was a meal in which the person eat sugar and a drink with a lot of sugar, and you can see that from the sweat we are able to see a peak that is here that shows that in the sweat we can monitor the peaks of the sugar. And this can be very interesting because for diabetes people, people who have diabetes, they don't need to take the punch and take the blood for the analysis, but you can directly analyze the amount of sugar directly from the sweat. And you can do it continuously in time. So you can see also if the sugar has the correct time to reduce after you have eaten, or you are going to make too much time, and so you are going to pre-diabetes, and you are going to have some problem. And this is a very important monitoring device that can be used for the persons every day. So with this device, you can have application which we can monitor from the sweat different analytics, sodium, glucose. We are working also on urea that can be used for the screening of kidney disease, and potassium that has a connection with the heart problems. So the idea is to develop this non-invasive approach to understand what is happening in the body in real time, monitoring in real time these parameters, and try to understand if the body is going in muscular fatigue, or is going to dehydration, or is going in stress, and can give to the person some alert to improve their health and their well-being. We have also medical application of the device we use for the wound exudate, in which we apply on the wound that are very large. They want to know if the wound gets infected. We apply with this device directly on the textile of the bandage, and we look at the pH. We see the test different pH. The device changes in function of the pH. And we were able to understand if the wound is going to be healthy or is going to have problems. Another application of this organic biocompatible device that we had in time is related to the world of plants, not human, but we decided to apply this biological sensor for fluids directly into the plants to monitor the sap of the plant. The idea is to build a device that is made by biocompatible material and has the same architecture of the device that I showed you before, in which you can have a channel of the transistor, you can have a gate of the transistor, and the two are connected by the liquid part that is between in the plant. We succeeded to do the devices because this material biocompatible. So when we inserted the electrodes with textile electrode inside the plant, we are able to monitor day and night variation of the ions concentration in the sap of the plant. And if we look at the damage that we do with using a metal electrode, you can see here on top or right, you have the plant is rejecting the electrode, the plant is being damaged by the electrode. Instead, on bottom left, you see the textile electrode made by organic conductive polymers. You can see the plant is not damaged and the electrode is accepted by the plant. this allows us to use this electrode for many days, and also for months inside the plant. What we can see if we look at the changes in the ions concentration in the plants, in the sap of the plants, we discovered that if you look at the concentration of the ions inside the plant, if you started to stress the plant, for example, not giving water, and make a drought stress in which the plant is not irrigated enough, the concentration of ions starts to decline. And then if you irrigate again the plants and keep the plants alive, you have the response that comes up again. And then if you stress again, you can see that the signal is going down again. So we have a direct monitoring of this hydric stress of the plant using this device that has been inserted directly in the stem of the plant and give you an indication in real time with what is happening to the plants. So with this idea, we applied our devices into tomato plants here in Parma, and we applied on different fields with different kind of irrigation, 100%, 80%, and 60%. And with this irrigation, with these devices, we monitor the tree thesis for all the growth of the plants from the beginning, for all the growth of the tomato for all the season, from June to September. And you can see that there are these spikes in the monitoring. These spikes relate to the raining events, in which the plant, when the rain arrives, closes their activity, they stop their activity, they don't take more water from the ground, and the ion concentration gets very soon high. And when the rain stops, the concentration comes back to the normal. And so we have a direct monitoring also of the raining events from the physiology of the plant. If you look at the different theses, 100%, 80%, 60%, you can see that the signal is dependent from the stress that the plant has. So the plant that are more stressed, we have a lower signal. The plant that has the plant that higher stress, we have a lower signal. The plant that has lower stress, we have a higher signal. So this signal is directly dependent on the stress of the plant. So the idea was to build a spin-off company that can bring this technology to agriculture, to use this technology to optimize the irrigation of the plants, to reduce the illness and the problems of the plants, and to reduce the use of fertilizer, because we have a system that can understand if the fertilizer are really needed. This spin-off company is Plantivate. We have started this company with the idea to monitor in vivo the plants, and we have built our electronics to monitor the devices. We insert the devices in the stem of the plant, and we monitor in real time the condition of the plant, knowing exactly how much water is needed. We tested on the tomato, as I show you, and at the end of the season, with our device, we were able to increase the production of 7%. We increased the sugar grade in the Brix grade in the tomato by 12%. And we reduce the waste of water of 45% during the whole season. So giving water in the right moment, only when the plant needs the water, allows us to save a lot of water and to increase the quality of the tomato of the plants. We apply this device to different plants species, kiwi, grapevine, apple tree. We are collaborating with different companies, producers, and they are buying their devices to monitor the plants and to optimize the performance of the plants. And our goal is to increase the number of devices, increase the number of selectivity of the devices to produce more and more information in real time directly coming from the plants. And so we can build with this data an algorithm that can give you the perfect, we optimize the water irrigation, the correct number of suppliers of fertilizers, and can prevent the presence of disease. We also have been to explore last year. And now I just show you another approach that we use for the application of the use of organic electrochemical transistor. We try to use a property of the surface, of a nanostructured surface, to make a specific condition for the liquid sample. In this case, we use a super hydrophobic surface that is made by this texture of the pillars that make the angle of the drop of the sample very round, so the angle, the contact angle is very high. And in this case, we have a motion of the solute in the drop that is very fast and very dependent from the position of the molecule inside the drop. So our idea was to monitor the condition of the solute inside the drop in different points, from the center to the border of the drop, in the place where the drop is take contact with the substrate. So in this case we have 5 devices in line that monitor the center and the border of the drop. With this condition, we can see that if you have different molecules of different sizes, a small molecule like adrenaline or a big molecule like cetyl-B, we have a different distribution from center to the border of the drop. We studied this distribution and we understand that we can distinguish heavier molecule and lighter molecule using this property of the substrate. We applied this analysis. I don't go too much in detail, but just to give you an idea, we applied this device analysis to the secreton of different patients that have tumor or are healthy, to understand if the distribution of the solutes in the drops of the secreton can give us information about the health of the patients. So we try to analyze all the samples and we monitor 50 patients after with cancer and after without cancer, and we can see that depending on the position on the analysis of the position on the substrate, we can distinguish 2 classes of samples that are separated. On top you have the healthy samples and on the bottom you have the people with cancer. So in practical, this device, by looking at this distribution of the molecule inside the drop, can tell you if the sample of the secreton belongs to a healthy person or to a not healthy person, a person that has cancer. So we were able to separate these variables and to make this system as a screening system to understand if the person can be in danger of having cancer or not. This is still a work that is going on. We are working on to improve this, but it's very interesting for the application. Then at the end, I just want to show you another approach using conductive polymer that we have been done for the building of other different sensors that are made by polymeric materials. In this case, we wanted to test a pressure device, and so we functionalize. The idea was to functionalize a soft porous material that is a polymeric material like polyurethane or other porous material like cellulose, nanoporous cellulose, or other material that are elastic, porous, and we use the conductive polymer to functionalize the internal part of the material and make this sponge, this elastic sponge, conductive. The idea is that being conductive, this sponge, when you press the sponge, you change the conductivity of the sponge because the vacuum chambers that are inside the sponge are conductive, are functionalized with the material that is conductive, and they collapse one on the other, making more contacts one between the other, and so increasing the conductivity. So this material, when you press it, you change its conductivity. So it's a sort of soft piezoelectric material. We make contacts on top and bottom, and we use this material to build a pressure sensor device that is also a soft material. Here you can see the internal of the material that is conductive, and these are the cells of the porous material that when they collapse, they increase the conductivity. So if you press the device, you can see we press 3 times, you can see the current changes. And so you can have a proportional response to this device. If you look at the pressure and the response, you can see that it's quite linear. And when you press the device, you have a linear response that can be used for to detect pressure. And then when all the cells are collapsed, you only press the elastic material, you change the slope of the response, but you have still an area in which the device responds. Then we study the response, the responsive frequency of this material, and we see that at lower frequencies the response is very high. Then at 100 Hertz, more or less the response is reduced because you need to wait for the elastic response of the material. So with this material, we had the idea to build some devices, in this case an insole that is made by soft porous polyurethane material that is being functionalized with the conductive polymer, and we deposit on the top a film that is printed, a polymeric film that is printed with silver contacts. And in this way, we have a device that is made all by polymers, and is a sensing device of the pressure of the foot on the shoe. So you can have the different points, so you can read, if you walk, you can read the pressure applied in time at the different points of the shoe. We also try to build a specific 3D printed material that are being functionalized with conductive polymers in such a way that if we press this material, we have a response here that is a sort of pressure sensor made by 3D printing, and this can also be made in different shapes. We tested for insole. Here you can see that has a specific dynamic range, and you can apply this kind of materials for different industrial applications. We have a collaboration with an industry for the mattress to monitor the position of the patient in the bed, especially patients that are forced to stay in bed and they want to know if the position is correct or not. So we sensorize a whole mattress using this soft pressure sensor. And we collaborated with the industries for car seats to monitor the position of the driver. We built the sensorized insole. We built a glove that has a soft sensor inside that can be also used for robots and can be interfaced with the robots and so on. So I just show this is the mattress, the response of the mattress. I just show you if you press the different sensor in the mattress, you can see you have a linear response. You have a response on the different position of the mattress. And if you test the position of the person on the mattress, you can see on the left you have the response in time of the position. and you can say if the position of the person is correct, if he has to change for different pathologies during the bed. Okay. Just to give you an example. So at the end, I want to conclude my speech by telling you that we are working on materials that are very interesting because they are flexible, they are biocompatible, can be used in different situations, and we try to use these materials to build devices that are different from the common devices. We try to exploit the property of this device to build something that is non-common in industry and in literature. And we succeeded to do this in many wearable applications and also in plants. And their approach is to make this sensor more and more integrated in the life or everyday life, to have more data directly from the person, and this data with the use of artificial intelligence can be used to build models that can give us real information on our health, how to behave in our everyday life and well-being, and also for the health of the planet. So I stop here. Thank you very much. And let me know if you have questions.
Well, Dr. Nicola, thank you very much. We appreciate you for sharing with us. And we do not if time will permit us to entertain some questions before the end of the program, but not now, not yet. So, ladies and gentlemen, once again, we thank you for your patience. We thank you for listening attentively to all these papers that they have for us. Well, even though we don't have any matches to test with, can we just stand, rise to, just stretch? Let us just do that. Yes, we just stretch our bodies. Because we've been sitting for over an hour now. All right. Thank you very much. When you are done, you can sit. When you are done, you sit. Okay, ladies and gentlemen, for those who started with us, I told you it's been an eventful week for us. And yesterday was the faculty lecture, which was delivered by our distinguished Professor Lucia Gomoni Ige, the DG, Nigerian Geological Survey Agency, Abuja, who is there with us again to be part of this. Please, let's appreciate Professor again. Thank you very much, sir. And I'd like to also appreciate and welcome one of the experts from the faculty to serve the university at the postgraduate level, Professor Onwosu. You're welcome, sir, once again. And we'd like to also welcome and invite to join the Dean up here, our former Dean. He was the last Dean of Faculty of Science and the pioneer Dean, Faculty of Physical Sciences. And currently the Chairman, the Unilorin alumni, Professor Babatunde Lateef Adeleke. You're welcome, sir. I'd like to also recognize the presence here. Professor Adejumo is also one of the LOC people. You're welcome.
I'm going to give you that small thing, though.
What are you giving us? Technical, please. Take charge. And we'll welcome also the Director ComSits, Professor Rashid Bengajimo. You're welcome, sir. Well, we have one more lecture to listen to, but just before that lecture, I'd like to invite the LOC chairperson for the next thing, while our performers are also getting ready. But then we quickly want to get this done so that we can allow our DG. LOC chair.
On behalf of the LOC Chair, I would like to call on Professor F.A. Adekola to present gift to Professor O.O. Ige, the DG of NGSA. Let's put our hands together.
Good afternoon, dear participants. On behalf of our Vice Chancellor, Professor Wahab Olasupo Egbewole, SAN, we are presenting this token. We are presenting this token as a sign of appreciation to our brother, the Director General, Nigeria Geological Survey Agency, Abuja, Professor Olusegun Ige, FMGS. Okay, congratulations, sir.
And next to be gifted is Professor Jane Kachin Ngila. And this is to be done by the Dean of the Faculty, Professor Olabisi Adeke.
So on behalf of the University of Ilorin, our able Vice Chancellor, Professor Wahab Olasupo Egbewole, SAN, in conjunction with the Faculty of Physical Sciences, in appreciation of your honoring our invitation to come from all the way from Kenya to Nigeria to deliver your keynote address. So we want to show this little appreciation. And anytime you see it, you remember University of Ilorin. So thank you very much.
And so, ladies and gentlemen, let's welcome our performers from the Department of Performing and Film Arts. You're welcome.
Good afternoon, distinguished ladies and gentlemen. You are welcome to this second biennial conference with a very fantastic theme. We are all lucky here, especially physical scientists, because you are doing a lot to protect lives and the environment, and you are also innovating to ensure that our present and our future is right. However, it has come to my notice that many who perhaps studied sciences in their secondary school turned their back on science, venturing into other fields. They do not know what they have lost. I'll be showing you 3 scenarios to exemplify the theme of this conference, and I hope you learn and enjoy. Please, watch.
Rotimi? Who is this boy? Rotimi? Is this boy not in this house? Rotimi? Rotimi?
Mommy, were you calling me?
No, I was not calling you. I'm only telling you to stop taking this class now. No, you couldn't hear me because of how I default on me. So why are you like this?
I'm sorry, man. I'm sorry, man. And Mommy, there's something I want to discuss with you.
So if I did not call you, you don't know you have something to discuss with me.
I'm
Oh
sorry.
yeah, I'm all ears, Mungwe.
I know my father will not like this if he's alive. But this is where my heart lies. I want to go and study music in the university, Mommy.
Study music?
Yes.
But why music? There are other important courses in the university to study.
That's what I thought.
Other children, they go to the university to study science, law, engineering, and all important courses. Why music?
Yeah, that's what I like, and that's what I'm going to study.
Thank God you also said it at the beginning that your father will not want you to study this. Then why do you want to go and study it?
I know if he's alive, he will not want me to study it, but he will be happy in heaven that I'm studying music.
No, that is a no-go area. You cannot study music. Lie, Osheshe, you cannot study music. Want to go and study music. My friends now ask me that, what is your son study? I will not say music. It is not even palatable to the ear. That is not possible. The reason why I called you initially, I want to tell you that, see this boy, yo. God, please help your coach this very matter. Hey.
His father studied sciences, especially physical sciences, and he wanted the boy to take after him. But immediately the father died. He said he was going to the university to study music. Consider physical scientists are the luckiest because they could go to the university to study physical science and still venture into music. Davido did not study music. Whiskey did not study music. But you can do physical science. You can explore dimensions of innovation, technological innovation, scientific innovations, and still do music. The students who are here, I enjoy you and I implore you to venture into physical sciences so that you can be able to innovate and produce significant innovations that will shape our future. Again, today we are experiencing a very, very difficult time in terms of security of our environment. I need to let you know that innovation can help us in this area. Please watch.
Girl, are you hearing about what's going on in this country? This insecurity is becoming too much. Even before I even step my foot out of my house, I'm already scared that something bad will happen to me. I'm tired of living in fear. I'm tired of living like this. I cannot do this anymore.
Why you are complaining? I have a lot to say. But where should I even start from? I don't even know. Imagine, they kidnapped over 40 students in Oyo
And you even know the funniest part? We still celebrated. What did your boy know?
Can you imagine?
Yes.
We didn't show this security.
Exactly. Even my brother knows of someone who thought was kidnapped by these bandits. Yes, a 3-year-old child at that.
As you spoke, so were saying, you go left, problem. You go right, problem.
I've been hearing you complain about these recent bandit attacks.
It's too much.
What if I tell you that science can solve this problem?
Science?
Yes,
How possible is that?
I will show you. In fact, science can solve this problem in a way that the government has not thought about. Let me show you something.
Please show us.
Can you see this?
What is that?
This is the work in progress.
Okay.
This can be held by just 2 students or 2 people in an environment in such a way that it blocks the perimeter of where they are and the bandits will not be able to invade. Like I said, it's a work in progress.
Wait, what about the shooting? Even if they cannot move, will the bullets still touch us?
Okay, that's another point. But this will block them and also block their instruments. They will not be able to shoot. All right, this is another one. This one will be with security agents, police, soldiers, so that this will be the trigger to let them know that some people have been invaded and even point out the location. Should I show you how it works? All right, hold on. Just hold this and I will show you how it works. Hold on. Can you see? They cannot invade. They cannot use their instruments until the security agents arrive and they detonate. Just watch. By the time I press something, they will be able to move. Can you see? Can you see? Can you see?
We can see.
Now, sciences and innovation can mitigate all this. It is still a work in progress, don't worry. But the problem here is funding. The problem is funding because the government has not really responded to funding scientific innovations, especially the ones that save lives and properties like these ones. Ladies and gentlemen, they are not bandits, we are only acting. Thank you very much. Now, let me let you know, I know one of you may be asking that money is the important thing in this situation, right? Now, let me let you know something. Imagine that in 36 states, including the Federal Republic of Nigeria, the bandits go there to invade, and they ask for 100 million. How many bandits will the government pay? But if they invest in technology, and if a set of bandits, the second set, they know that they cannot block the perimeter and they will be caught by the security agencies, they will not venture. They will not try. And then the government will do a lot about security with science and innovation. They will also do a lot by stopping these dangerous activities. My people, let us get the government to invest in science and innovation. Federal government, please invest in science and innovation. All right, thank you very much. Distinguished ladies and gentlemen, we also have one more to show you. And this, in particular, speaks to all students here. There are lots of things that we do to pollute the environment, our physical space. In fact, I was in the rain one day and I saw 3 women who work in the canteen, who sell in the canteen, going into the rain to dump their refuse. This is harming our physical environment. Please watch this last one.
They did not come again. Now I'll go and throw this thing anywhere I see you. Abi, when rain falls, you to throw everything away. Let us go.
Sorry, good afternoon, ladies. Where are you going to?
I'm going to throw it inside bush.
Inside the bush?
Yes.
Don't you know disposing waste is bad now? Look at you, want to go and throw it in the bush. How?
What do you know what those to throw it?
No, now.
They are not around now.
The government's provided places where you can dump waste properly.
Places have been seen.
Okay, let me just say this. It seems you are not enlightened on how we can recycle this waste and turn them into useful materials.
Recycle waste.
Yes, I'm even training 100 youths on how they can be independent and be able to recycle waste themselves. Okay, don't worry. Just hand it over to me. Don't worry. Bring it. Bring it.
Yeah.
Don't worry. Don't worry. I'm going to invite you to my company soon so you can see what useful products this waste have turned into. Don't worry. Let's go.
Yeah.
Let's go.
Ladies and gentlemen, these wastes that you throw about can be useful if disposed properly. And this is also to go to the federal government, the state governments, institutions, to provide places where we can put this refuse and put them to good use so that our physical environment can be better. In view of the positive points that we will generate in this conference and the colloquium which will be sent out for improvement and investments in physical sciences, please enjoy this short dance. Thank you. Thank you for watching. God bless you. Hold on, go and check that.
Please, another round of applause for them. When you must have spent hours in your laboratories and you need to cool off, those of us in humanities are the ones to entertain you, just as you have been entertained now. So we are all useful in our various areas. So thank you very much. And if you're next you want to talk about people who run from sciences to other area, just face me directly. I don't like people talking corner, just come out straight. And I said it earlier anyway. And of course, on security matter, that's actually a challenge to all of you scientists. Let's see what we can do in that area. Because lives and properties we need to really protect so that we can all be in peace. And indiscriminate disposal of our wastes, of course, not in our interests. Thank you very much. Our performers from the Department of Performing and Fine Arts of the university. Please, another round of applause for them. Well, the last paper to listen to now, ladies and gentlemen, it's going to be physical, unlike the virtual we listened to just about now. And we want to welcome, and just before we welcome her anyway, we have a citation to be read, and this will be done by Dr. Omonroye. But, ladies and gentlemen, for the next couple of minutes after the citation, we shall be listening to the voice of our former Dean of Education, University of Ilorin here. If you missed inaugural lecture, this is an opportunity to listen to her. She's from the Department of Science Education. You know, as I told you earlier, all that we are doing in other departments and faculties, we have it duplicated in the Faculty of Education. So, distinguished ladies and gentlemen, and currently she's serving as the Vice Chancellor of Kwara State University of Education, Professor Medinat Folarunsho Salman. We will take her citation first, so I'm inviting Dr. Omariman.
It's a profound honor to introduce our keynote speaker, a trailblazer whose life work serves as a masterclass in resilience, academic rigor, and visionary leadership. Professor Medinat Folarunsho Salman is a professor of mathematics education and a distinguished alumna of the University of Ilorin, whose name has become synonymous with excellence in the Nigerian educational landscape. Our journey into the upper echelons of academia began with a focused commitment to the noble profession of teaching. From our foundational years at St. Clair's Anglican Girls Grammar School, Offa, she moved swiftly to acquire a Nigeria certificate in education, establishing an early mastery of pedagogy. This quest for knowledge led her to Ahmadu Bello University, Zaria, where she earned a bachelor's degree with honors, and later back to the University of Ilorin, where she attained both her master's and doctorate degrees in mathematics education. As an administrator, Professor Salman is a record breaker and a glass ceiling shatterer. At the end of University of Ilorin, she served with merit as the head of Department of Science Education and eventually made history as the first female dean of the Faculty of Education. Her transformative leadership and mentorship in those roles prepared her for her current epoch-making assignments as the pioneer Vice Chancellor of the newly established Kwara State University of Education. Our scholarly contributions are equally formidable. An authority in our field, Professor Salman has authored over 70 publications that challenge traditional teaching methods and advocate for gender equity in the mathematical sciences. Beyond the written word, She has successfully birthed a new generation of academics, supervising dozens of master's and PhD candidates, and serving as a trusted external examiner and curriculum accreditor across the nation. Our impact resonates far beyond the ivory tower. A former chairperson of the Mathematical Association of Nigeria, Kwara State Chapter, and a fellow of numerous professional bodies, she has dedicated her life to the intersection of scholarship and service. She is an inspiring speaker and a community leader who believes that education is the most powerful tool for women empowerment. Distinguished ladies and gentlemen, to deliver today's keynote address, please join me in welcoming a beacon of leadership, a scholar of international repute, and the first Vice Chancellor of the Kwara State University of Education, Professor Medinat Folorunsho Salman.
My Vice Chancellor, Professor Wab Olasu. My Vice Chancellor, Professor Wab Olasupo Egbewole. My co-keynote speaker, Professor Jane Ingila. And the other speaker, Professor Nicholas. I want to seek for permission to stand on the already established protocol. I want to start by the topic of my presentation is relevance of mathematics in addressing the challenges of sustainable development. Let me start from the dancing that took place now. I was telling my co-speaker that what they are doing involves mathematics. There are many things that we do and we do not have the knowledge of, we do not understand that there is mathematics in it. There was a time I conducted a study. We have among us pupils and students from primary and secondary schools. And the foundation of mathematics starts from there. Once they did not get it right from there, all the presentations that we have been watching, the content may appear a bit advanced because it's not for their level. And there are a lot of misconceptions. In that research, I sought for their conception about mathematics. And the responses, two of the responses, was that mathematics is a bundle of nonsense that has no relevance to their life. Another one is that it's just a mental exercise, just to disturb their brain and nothing else. And that is why most times when the teacher is teaching them, they are not paying attention. Some, they just engage themselves in other things. And when you ask, they tell you that all you are saying has no meaning to them. So what I am saying in essence is that everyone needs knowledge of mathematics to survive. In every day of activities, we make use, we are all users of mathematics. It's only when you now come to study at advanced level, then you see it as mainly involving calculation. Because the bricklayer cannot survive without the knowledge of measurement. The tailor cannot. The market woman cannot survive with that. So everybody needs a bit knowledge of mathematics for survival. So
The 2030 United Nations Sustainable Development Goals also requires a lot of mathematics, bringing it out of calculation and showing the reality. And why the foundation is having issues is that the presentation, the pedagogy, and everything we use, we do not show the real application and where you can find them in our day-to-day life. As for students to understand. So for you to be a good scientist, all what they are presented have mathematical, there is none. Both chemistry, both the material, both everything. You have graphical, a lot of graphical illustrations that a layman cannot even understand what is there without understanding mathematics. So now let me go to my presentation. Under my presentation, I have highlights of where we need mathematics to address sustainable development to attain those 17 United Nations goals. One, moments that demands intellectual courage. Distinguished scholars, respected eminent scientists, ladies and gentlemen, I stand before you today not merely as an academic administrator, but as a fellow traveler in a defining moment of human history. We find ourselves at a crossroads that demands more than technical proficiency. It demands intellectual courage, moral clarity, and a renewed sense of scientific responsibility. I am deeply honored to address this second biennial Physical Sciences Conference. We are gathered here in 2026, a time when the polycrisis, the intensified entanglement of climate, economic, and social instabilities is no longer a theoretical projection, but a daily reality. The subject of my address, relevance of mathematics in addressing the challenges of sustainable development, is therefore both a timeless academic pursuit and an urgent survival strategy. We are living in an era where the fate of humanity is intricately tied to our ability to understand, predict, and respond to complex systems. From the fertility of global markets to the fragile tipping points of our ecosystems, from pandemic that ignore national borders to the persistent iniquities that haunt our urban centers. The challenges we face are not isolated silos. They are interconnected, dynamic, and most importantly, profoundly mathematical in nature. Yet, tragically underutilized. Profoundly mathematical in nature. Yet, amid these complexities, mathematics remains one of the most powerful, yet tragically underutilized instruments at our disposal. It is time we move mathematics from the periphery of calculation to the center of consultation. The second highlight, mathematics beyond numbers, the architecture of reality. Mathematics is often misunderstood by the public and sometimes even by our peers in the humanities as a rigid discipline confined to cold logic and dusty textbooks. In its truest essence, mathematics is the architecture of reality. It is the universal language through which we interpret the cosmos. In physics, it is the curvature of space-time. In chemistry, it is the precise symmetry of molecular bonds. In biology, it is the algorithmic code of the genome. So what we are saying is that mathematics is the science of It's the language of all the sciences. So none can operate in isolation without mathematics. So every sustainable solution begins with 3 fundamental steps: measuring what is currently happening, modeling why it is happening, and predicting what will happen next. Mathematics provides the syntax to achieve this, transforming raw and chaotic uncertainty into actionable insight through stochastic modeling, multivariable analysis, and combinatorial optimization. To attain sustainable development without mathematics is to attempt to navigate the treacherous currents of the Niger River in a storm without an anchor, a rudder, or a oar. The next one, the mathematical lenses of sustainability. Sustainable development is often framed as a political or an economic choice. I argue today that it is fundamentally a mathematical necessity. The United Nations Sustainable Development Goals, you have 17 of them, represents a delicate optimization problem. We must maximize economic growth and social equity with operating within the finite constraints of a planet with limited resources. This is the very definition of constraint optimization. Whether we are designing smart cities that minimize energy dissipation or managing groundwater levels across the Sahel, mathematics is the silent force guiding our decisions. Consider the complexity of the Nexus approach. The realization that water, energy, and food systems are insubordinately interconnected. A change in one variable invariably affects the others. Only through advanced mathematical systems analysis can we prevent a solution in energy from becoming a disaster in water security. Climate change. When numbers reveal objective truths, perhaps no global challenge illustrates the gravity of our discipline more than the climate crisis. In an age of alternative facts, rigorous mathematics remains an indispensable anchor of objective truth. Climate change is not a matter of political opinion. It is a matter of thermodynamics and fluid dynamics expressed through differential equations. Our current climate models, the very models that warned humanity about the 1.5 degrees Celsius threshold, rely on massive computational algorithms and statistical inference. However, we must remember that mathematical models are only as reliable as the integrity of their assumptions, placing an immense ethical burden on the mathematician to demand rigorous data against manipulation. When data reveals accelerating glacial melts or statistical deviation in rainfall patterns, it strips away the luxury of denial. In this context, the mathematician is not merely a researcher. The mathematician becomes a witness, and our equations become the voice of clarity in a world of noise. Food security and the mathematics of survival. In Africa, and particularly here in Nigeria, food security is the bedrock of national stability ensuring that every citizen has access to safe and nutritious food is not only an agricultural challenge, it is also a logical and mathematical one. Today, mathematical modeling is actively saving lives by integrating satellite data to predict crop yields, utilizing graph theory to minimize transportation distances, to cut down our plaguing 40% post-harvest losses, and deploying statistical probability to accelerate drought-resistant genomic selection. In a world where millions still go to bed hungry, mathematics is not merely an academic exercise. It becomes a tool of justice and a guardian of the right to life. Public health and economic precision. The lesson of the past decade have taught us that a virus can shut down the world within weeks. Mathematics therefore acts as a guardian of life. Epidemiological models such as the SIR model and its variants allow us to simulate outbreaks before they happen, thereby informing vaccination strategies, emergency preparedness, and resource allocation. Mathematics transforms reactive fear into proactive foresight. Similarly, in the realm of economic stability, we cannot afford speculative policies. In an interconnected global economy, we require the precision of data science and econometrics to forecast trends, evaluate subsidies, and assess the impact of physical and monetary adjustments. In the absence of mathematical insight, economic decision becomes gambles. With it, they become strategic blueprints. Africa's moments from potential to power. Africa stands at a pivotal moment in history. We possess the world's youngest population and an abundance of natural resources. But potential is not the same as power. Potential is stored energy. Potential is that energy purposefully directed to drive systemic change. To transition from potential to power, Africa must lead in the mathematical sciences. From the Silicon Savannah to the growing industrial and technological hubs across Nigeria, mathematical thinking is becoming the engine of digital innovation. We must stop being mere consumers of global technology and become creators of the algorithms that increasingly govern our lives. We must invest deliberately in our young people, demonstrating that a secure laptop, coding infrastructure, and a deep understanding of calculus can be infinitely more valuable than any raw material buried beneath the ground. Reimagining education from Kwara State to the world. If mathematics is to fulfill its true potential, we must fundamentally rethink how it is taught. For too long, mathematics has been perceived as a gatekeeper discipline used to filter students out rather than invite them in. At Kwara State University of Education, we are championing a paradigm shift from memorization to meaningful application. Our new educational compass mandates that we teach mathematics as a living discipline connected to real-world challenges, integrate artificial intelligence as a telescope for advanced discovery rather than a crutch, and foster interdisciplinary collaboration so that equations are directly married to ecological and economical realities. Our goal is not to produce human calculators, it's to produce architects of solutions. Moral imperative, the responsibility of knowledge. As scholars and scientists, we carry responsibilities that previous generations could not scarcely imagine. Knowledge is not neutral. The application of mathematics can either build surveillance systems or empower citizens. It can optimize the extraction of fossil fuels, or it can optimize the transition to green energy. We must therefore ensure that our work serves humanity. The true measure of our success as scientists is not merely the H index of our publications or the number of citations we accumulate. It is the number of lives improved, the hectares of land restored, and the number of children fed because of the precision of our models. The future we must create. Ladies and gentlemen, the challenges before us, namely climate change, inequality, food security, and economic instability are immense. But as mathematicians and physical scientists, we understand that every problem has a structure. Every complex system has a pattern. And every challenge, no matter how doubting, contains a solution waiting to be discovered through the rigor of disciplined thoughts. Let us depart from this conference empowered not just by new data sets, but by a renewed oratorical and intellectual mission. Let us commit ourselves to using the power of the mathematical sciences to build a world that is not only sustainable, but beautiful, not only resilient, but equitable. The future is not a predetermined destination towards which we drift. It is a structure we are building in real time. And with mathematics as our guide, we possess the power to build it wisely, to build it strongly, and to build it for everyone. Thank you for your time. Thank you for listening.
Well, ladies and gentlemen, another round of applause for Professor Medinat Salman. Yeah, thank you very much, man, for making the lecture lucid, concise, structured, evidence-based, relatable, and actionable one. Because when you need to buy something and you need to take money back, you know that you need the knowledge of mathematics. When you work for somebody and your money is not paid completely, you know that there is a need for you to have that knowledge of mathematics. And of course, just as she has said, from all of the examples she gave, we truly need that knowledge of mathematics, especially when Naira is added to the figures. All right, thank you very much, man. Ladies and gentlemen, and these are the papers for today, and we want to thank all our keynote speakers, starting with Professor Jane Ingila, to Dr. Nicola Kopede, and also Professor Medina Folorunso Salman. Please, together, let's appreciate them one more time, ladies and gentlemen. Gradually, we're coming to the end of the program, but just before the vote of thanks and some other things we have to do towards the end, in the program we have a goodwill message, and to all of the people you've been listening to before now, they will be physical scientists. Now you want to hear another opinion. And so we're inviting the Dean, Faculty of Agriculture, Professor Israel Ogunlade, who is ably here represented by a forester, a big-time forester in Africa, Professor Folaromi Dapo Babalola. A good message, just in 1-2 minutes, sir. They're not clapping for you because they don't know your worth. But just Google the name and see where the name has traveled to all over the world. Once again, the name is Professor Folaromi Dapo Babalola.
Thank you so much, sir. And thank you so much, Mr. Shegun. I want to stand on existing protocol, but let me appreciate all our lecturers for today. And let me appreciate the Vice Chancellor of the university too, and all the principal officers that were here before and gone. As rightly mentioned, I am from the Faculty of Agriculture, but I'm a forester by profession. I study forestry, and I do forestry, and I'm proud to be a forester. At least, why did I say that? Forestry has taken me over the world, more than 30 countries of the world that I've been to, including UK, US, Australia, New Zealand, Canada. Mention the country that I've been doing forestry. And I've been to South Africa because of our presenter of today. Even when I was in South Africa, I was given a permanent residence. I lectured at the University of Pretoria, and I was given even a scholarship for supervising their masters and PhD at the University of Pretoria. So you can see forestry is a proud thing to do. But I'm not jealous of you people, because without you, there's no forestry. Without mathematics, without chemistry, without physics, there's no forestry, because you need that to study forestry. You need that to study agriculture. So congratulations to every one of you studying physical sciences and studying every other courses in sciences. Congratulations to every one of you. So I bring you greeting from the Faculty of Agriculture on behalf of my Dean. I'm representing the Dean here today. And I bring you greeting from all the departments in other non-sciences, non-physical sciences program in the university. And this is a second version of this conference, which is starting today. And I want all the presenters that are going to present papers in this conference to look at the applied versions of what you are presented. Yes, we know 2 + 2 = 4. We know the formulas in chemistry. We know what is in physics. My best subject when I was in the secondary school was mathematics, followed by chemistry, and then biology. Biology, they didn't even teach me biology before I knew biology, because I read modern biology textbook cover to cover, and I had A1 in my WAEC. So what I'm just trying to say is, please let us look at the application of all those researches as has been demonstrated to us by the drama team. Please look at how we can apply our physics, chemistry, every other courses or subject that you are studying. How can we bring it on board? How can we make it an impactful program, impactful subject? So without wasting your time, once again, I congratulate everybody for coming to this conference. Make impact. network, collaborate, know people. If you are able to connect, you don't know what that will take you in the future. And I say thank you again for inviting me, and thank you also for coming. Thank you so much.
Physical sciences. When will you change? Even when you are commended that without you, no forestry, you still could not clap for yourselves. Okay. Oh. All right. Thank you very much, Professor Babalala. We appreciate you so much for what you're doing for our physical environment. And ladies and gentlemen, well, our refreshments are here and ready. We're just waiting for the rain to go down so that the people having them can have can come in and serve us. So just remain where you are, it will get to you. But for now, distinguished ladies and gentlemen, I want to invite Professor Alimat Adegoke. So before you clap, it must be a lady professor from physical sciences. Okay. It shows how loved you are in the faculty. Please, another round of applause for her. Thank you for the motherly role. It shows. Yes, Professor Adegoke is here to perform a role, and this is on behalf of the Vice Chancellor and the Dean, and also the faculty, do this presentation of the token we have for our keynote speaker, Professor Medinat Falansho Salman.
Thank you very much. Good afternoon, everyone. On behalf of the university community and our Vice Chancellor, Professor Wahab Olashupo Egbewole, I'm to present this token. I'm to present this token to our own Professor Medinat Falansho Salman, the Vice Chancellor of Kwara State University. We appreciate you, Ba, for enlightening us on relevance of mathematics in addressing challenges of sustainable development. Thank you very much for honoring our invitation.
Well, we say thank you to our Vice Chancellor, Kwaswed, Professor Salman. Thank you for your time. She's been here since morning, even before the start of the program. So we appreciate you so much. Thank you. She's taking her leave now. We appreciate you. And ladies and gentlemen, I think All right, we're bringing everything to a close for the opening ceremony of this program. And I want to invite the secretary, admin to LOC, the faculty officer, Mrs. Modupe Adekomi, for the vote of thanks. Again, I reintroduce the faculty officer, Mrs. Modupe Adekomi, for the vote of thanks. You know, she's the registrar in your faculty.
Good afternoon, ladies and gentlemen, esteemed speakers, and honored guests. As we come to the close of opening ceremony, I take this moment to express my heartfelt gratitude to every one of you on this event of Faculty of Physical Sciences Second Biennial International Conference, themed Future Frontiers, Science and Innovation Shaping Tomorrow. It has been an honor to be part of this innovative event, and on behalf of the Faculty of Physical Sciences, I appreciate your presence, participation, and contributions that have made this event a memorable one. To the erudite speakers, your insights, brilliant thoughts, process, expertise will inspire and educate tremendously, and we are grateful for the time and effort you dedicated to creating and sharing your knowledge with us. To all organizers, from the committees and subcommittees, the local organizing committee, and all volunteers, your unrelenting efforts will ensure a fruitful experience for all attendees. Your hard work and dedication have not gone unnoticed. To all our attendees, your engagement in form of questions, remarks, and interaction will undoubtedly make this FASCON 2026 a dynamic and enriching experience as we pose to serve you as the best we can. Thank you for being part of FASCON 2026. It is favorably anticipated that we create memories, network effectively, and apply innovative scientific knowledge gained here positively as we continue to inspire and motivate one another in our future endeavors. Please join me in a round of applause to express appreciation to our Vice Chancellor. Please, let's put our hands together. Professor Wahab Olashukwu Egbewole, SAN, for his visionary leadership, prompt response to requests and side guidance regarding actualizing FASCON 2026 by Annual International Conference. Please, another round of applause to appreciate our Dean, Faculty of Physical Sciences, Professor O.A. Adekeye, for tirelessly interacting with all facets of organizing committees to ensure prompt progress. In the same vein, I salute all past deans of this great faculty, all our erudite professors, the heads of departments, present and past HODs, and all non-teaching staff of this great faculty. You are all wonderful. Please, let's put our hands together again for the chairperson, LOC, Professor Olubumin A. Fadipe Joseph, for our progressive leadership and ingenuity in making this conference a reality. Last and of utmost importance, a resounding round of applause. Let's put our hands together. To all participants, let's put our hands together to all participants. Without you, there will not be events to grace or remember. Thank you for your presence and prompt support. I also want to appreciate our pupils from and their teachers from the secondary school
Thank you for coming. On behalf of the Faculty of Physical Sciences, I also welcome you to the University of Ilorin as you enjoy this FASCON 2026 event. I wish us all happy deliberations. Thank you.
All right, we thank Mrs. Adekomi. Thank you very much, ma'am, for thanking us. But you didn't thank the MC, so the MC is saying thank you, MC. Thank you. So I got many thank you from our KBSC and our distinguished professors. Professorial thank you I got. Thank you. Do we have anyone who has not gotten refreshment? Thank you. I want to believe everyone on this side, you've gotten your free refreshments. Also on this side, you've gotten your refreshment. Raise your hands. You're not listening again. Professor Wasil Raji, where have you been? We are not done yet. Where are you leaving? Please remain where you are. Do you have any question for Professor Ngila? Any question? Our pupils, do you have any question for Professor Ngila? Please, let's take that to our pupils. Invite, oh, they've taken, okay. Prof, please sit down. Don't worry, if there's any question, we'll pass the microphone. Do you have any question for Professor Ngila? Someone said yes. Okay. Please, can we have a mobile mic? Please don't leave yet. We want everybody to be served before we leave, before we do the anthems. So just remain where you are. Your refreshment will get to you. Don't change your seats. Anyone found standing should not be served. Yes, the mic. First, have you been served? Okay.
Good afternoon, ma. My name is Amzad Abdullahi. I'm a final year student of the Department of Chemistry. So, first of all, I want to say thank you, ma, for that wonderful presentation. So, while you were giving your presentation, you made mention of recent advancements in water treatment method. You mentioned the smart water monitoring, which involved the use of Internet of Things coupled with AI. So my question is that we know that in Africa, there is a barrier regarding the issue of inadequate funding and infrastructure. So how feasible have the issue of smart monitoring system, how feasible has it been in Africa? Like how far have that advancement moved in Africa?
Thank you very much for the question. This is a very brilliant question, particularly coming from the youth. As you know, smart technologies are increasing. We are not yet, can you say in Africa, we still have a bit of time to go. But we are also comforted by the fact that in Africa, we have got one of the most progressive regions in terms of discoveries and innovations. So as much as we cannot get the smart technologies for water monitoring at every single wastewater treatment or any place water treatment, we still have a sizable number of technologies that we are using now to monitor what is happening on the ground. If it is leakages in the water infrastructure, in terms of distribution, we have got smart sensors to monitor the leakages and all that. So the final question, the overall answer is, as much as we may not have smart sensors everywhere, the percentage and the numbers of the smart technologies are in the increase as we progress in particularly in Internet of Things, smart technologies, as we continue with internet, not internet, but digital transformation, digital tools. So that is going to be very easy going forward in the future, that it will be very possible to monitor what is happening in terms of either water wastage, leakages, and also coming up with the infrastructure that is going to mitigate the problems that we are faced today in terms of water supplies. Thank you very much for the question.
Thank you very much, ma'am. Do you have another question? Someone is ready. Please, can you please come down? Do you have another question? I think his question will be our last. Or do we have another questionnaire? Please kindly remain where you are so that your refreshment can get to you. There's enough for everyone.
Good afternoon. My name is Zubair Hussein, a final year student in chemistry department. When you're speaking on water treatment and water remediation, you talked about the concept of carbon dots and nanotechnology, and I'm particularly interested in this aspect. Now, one of my major concerns is that these things, many of them make use of organic and materials in which, like wastes, that we use in water remediation. Now, when we use them on the hybrid and on the lab scale, they tend to pose no risk. But is there any acceptable framework for a possible adverse effects of these things when they enter into the multi-sewage system, or is this still an open question? Thank you.
Have you been served? Hello, please, let him get his own there.
Again, thank you for that question. Should I understand the question to mean that when we are using technologies for wastewater treatment, whether nanotechnology is relevant? Gentlemen, is that your main question? So if that is the question about nanotechnologies and wastewater treatment, is that a question? Okay. So if that is the question, thank you for the question. I know that when we look at the most recent applications of nanotechnology for water treatment, it tends to be more prevalent in drinking water, particularly using membranes, nano composite membranes for water purification. It is very prevalent, particularly in the West. If you look at in the US, Florida is very well used for water supplies, drinking water supplies, as well as in Germany as well. In Africa, we have got filters whereby you just get a bottle of water and you put like this cup here, could be a filter that is impregnated with nanomaterials. And so as you drink your water, it filters instantaneously, instantly. However, when it comes to the wastewater treatment, because of the what we call the fouling, you see, wastewater has got a lot of matrix, has got a lot of sample matrix. So therefore, it kind of blocks the pores of the membranes. And so therefore, membrane technology, nanotechnology, is not very prevalent for the wastewater because of the matrix. However, if we can use the membrane, if you look at the wastewater treatment plant, and you look at the end where the water is being discharged after being treated, most of the countries, they discharge the water into the rivers. So if you can be able to put a membrane at the last point before it is discharged into the environment, nanomaterials and nanomembranes can be very useful at that particular stage. But they will not be useful at the influence where the water gets in because of the matrix. It is very contaminated, so membranes there are not useful. They will only become useful at the end before you discharge the water after it goes through all the treatment stages. So that's where nanotechnology can be utilized. Thank you.
All right, ladies and gentlemen, we want to welcome the Dean of the Faculty of Engineering, Professor Joshua Olariwaju Olaoye. You're welcome, sir. And we have some guests of the university from NNPC. They are here for an assessment. Please, let's put our hands together for them. Thank you very much for being here. And distinguished ladies and gentlemen, I have the information that everyone in the hall has been served. So, immediately after the anthems now, don't forget the technical sessions will take place at SLT, geology, statistics, mathematics, and physics departments. So wherever you belong, you just move to the place. Ladies and gentlemen, shall we arise? First, for the national anthem, the first stanza. First for the university anthem, then the national anthem. The university anthem first. Technical. The university anthem. Of the greatest Unilorites. Are you ready? At the count of 3. 1, 2, 3. All right, thank you very much, everyone, for being here, for being a part of the second Biennial International Conference of the Faculty of Physical Sciences, University of Illinois. Please, there will be a photo session just outside of the auditorium here, and don't forget, to network. Use this opportunity to network, and don't forget also for the breakout sessions, you know where you belong. We'll be expecting you there. Thank you very much, everyone. My name is Shogun Alabi. Good afternoon.